Hello students, welcome to Master live crash course. I am Radhakrishna, your mathematics teacher. Our today's topic is complex numbers. I am going to revise some important concepts and methods through some problems. Let us take up the first question. The question is, if the modulus of Z1 is 2, modulus of Z2 is 3, modulus of Z3 is 4 and modulus of 2Z1 plus 3Z2 plus 4Z3 is equal to 4, then find the value of modulus of 8Z2Z3 plus 27Z3Z1 plus 64Z1Z2. All of you are aware that Z into Z bar is equal to mod Z square. All of you are aware of this formula. So, if mod Z1 is 2, then Z1 bar is equal to 4. Mod Z1 square is 4. Similarly, Z2 bar will be 3 square. It is 9. And Z3 bar is equal to 4 square, it is 16. Now, let us see how we calculate the value of this modulus. Modulus of 8 Z2 Z3 plus 27 Z3 Z1 plus 64 Z1 Z2. Now, we can write 8 as 2 into 4 and that 4 can be substituted as Z1 bar. So, this will be 2 into Z1 bar into Z2 into Z3. Okay. Similarly, this 27 is 3 into 9, that 9 can be substituted as Z2 bar, then it will be plus 3 into Z2 bar into remaining is Z3 Z1 plus that 64 is 4 into 16, that 16 can be substituted as Z3 bar. So, it will be 4 into Z3 bar into remaining term is Z1 Z2. Now, what is common in the 3 terms? Z1, Z2, Z3 is common in all the 3 terms. I will take it out. Then it becomes mod of Z1, Z2, Z3 into remaining is mod of 2Z1 bar plus what is remaining in the second term? 3Z2 bar plus 4Z3 bar. Now, mod Z1, Z2, Z3 can be written as mod Z1 into mod Z2 into mod Z3. So, it will be mod Z1 into mod Z2 into mod Z3 into this whole thing can be expressed as modulus of 2Z1 plus 3Z2 plus 4Z3 whole conjugate, because all of you are aware of the formula mod of Z1 plus Z2 whole bar is equal to mod of Z1 bar plus Z2 bar. The same thing is true for sum of three complex numbers. So, we can express mod of Z1 bar plus Z2 bar as modulus of Z1 plus Z2 whole bar. So, here conjugate of 2 is 2. So, I can write this as 2Z1 whole bar, this is 3Z1 whole bar, 3Z2 whole bar, this is 4Z3 whole bar. The term can be expressed as mod of 2Z1 plus 3Z2 plus 4Z3 whole bar. Now, the modulus of 2Z1 plus 3Z2 plus 4Z3 is given as 4. So, modulus of its conjugate is also 4. So, this is 4 and these three are given in the question. So, let us substitute mod Z1 is 2 into mod Z2 is 3 into mod Z3 is 4 into this modulus is again 4. So, what is the product now? 2 into 3 6, 6 into 16, 96. So, our answer is 96. Now, in this question the important point we discussed is this property and remaining all only manipulation, right. Let us move on to the next question. If Z1 square plus Z1 Z2 plus Z2 square is equal to 0, then the origin and the complex numbers Z1 Z2 form dash triangle. The options are equilateral triangle, isosceles but not right angled, right angled but not isosceles, right angled and isosceles. These are the choices. Now, from the equation we can write a quadratic equation in Z1 by Z2. How to get? Divide both sides by Z2 square. Then the equation becomes Z1 by Z2 whole square plus Z1 by Z2 plus 1 is equal to 0, dividing both sides by Z2 square. Now, this is in the form of the quadratic equation x square plus x plus 1 is equal to 0. We can find the roots by using the formula minus b plus r minus b root over b square minus 4ac by 2a. So, Z1 by Z2 is equal to minus b plus r minus means minus 1 plus r minus root b square minus 4ac. B square minus 4ac is minus 3 by 2, and this can be written as minus 1 plus or minus I root 3 divided by 2. And all of you are aware that minus 1 plus or minus I root 3 by 2 are nothing but omega and omega square, which are cube roots of unity. So, this is Z1 by Z2 is equal to omega or omega square. Now, let us see the Argand's plane. On the Argand's plane, this is x axis, this is y axis, this is origin. Now, suppose Z1 is here, Z2 is here, then let us see the modulus of Z1 by Z2. modulus of Z1 by Z2 is equal to modulus of omega or omega square. What is the modulus of this? 1. Modulus of cube root of unity is 1. Therefore, we get mod Z1 is equal to mod Z2. So, if the modulus is same, both are equidistant from the origin. This length is equal to this length. Okay. And what is its argument? Argument of Z1 by Z2 is equal to argument of omega or omega square. What is the argument of omega? What is the argument of omega? It will be 2 pi by 3. And argument of omega square 4 pi by 3, because cube roots of unity are 1 omega omega square, which can be expressed as 1 e power 2i pi by 3 e power 4i pi by 3. So, argument of omega is 2 pi by 3, argument of omega square is 4 pi by 3. Now, what is the argument of Z1 by Z2? It is argument of Z1 minus argument of Z2. Argument of Z1 is this angle and argument of Z2 is this angle. So, the difference of the arguments is nothing but angle between the line joining the origin and Z1 and origin and Z2. This angle is this argument of Z1 by Z2. What is it? 2 pi by 3 or 4 pi by 3. If we take 2 pi by 3, how will be the complex numbers Z1 and Z2? If one is here, another is here, this angle is 2 pi by 3. Now, observe the triangle formed by the origin and Z1 and Z2. These two lengths are equal, so it is isosceles, and this angle is 2 pi by 3. So, it is not right angled, it is only isosceles but not right angled. Answer is B. Now, if you check the remaining angle 4 pi by 3, this angle is 4 pi by 3. So, if Z1 is here, Z2 will be here. If this angle is 4 pi by 3, then what is this angle again? 2 pi by 3. So, in that case also these two sides are equal and the angle between them is 4 pi by 3. This side 4 pi by 3, this side 2 pi by 3. So, again it is right angled, not right angled but only isosceles. Okay. Let us move on to the next question. If mod of Z1 minus 2 Z2 upon 2 minus Z1 Z2 bar is equal to 1 and Z2 is not, mod Z2 is not equal to 1, find mod Z1. And this is a very important model. You should remember the approach. In problems involving modulus, usually we use the property Z bar is equal to mod Z square or mod Z square is equal to Z bar. In problems involving modulus, use this property. How to use this? Because square is not there. So, first we should square. Before squaring, cross multiply, then square. Then what will you get? Mod of Z1 minus 2 Z2 whole square is equal to mod of 2 minus Z1 Z2 bar whole square. Cross multiplying the denominator and squaring. Now, you can use this property. This can be expressed as Z1 minus 2 Z2 into its conjugate. Conjugate of Z1 is Z1 bar minus conjugate of 2Z2 is 2Z2 bar is equal to RHS 2 minus Z1 Z2 bar multiplied by its conjugate. What is the conjugate of the real number 2? It is 2. So, it is 2 minus conjugate of Z1 Z2 bar is Z1 bar into Z2. Now, let us multiply Z1 into Z1 bar mod Z1 square. Next, Z1 into minus 2 Z2 bar is minus 2 Z1 into Z2 bar. Next, this into this minus 2 into Z1 bar Z2. Now, this into this minus 2 Z2 into minus 2 Z2 bar. 2 into 2 4 plus 4 into Z2 Z2 bar is mod Z2 square is equal to, expand the RHS, two into 2 4, 2 into minus 2 Z1 bar Z minus Z1 bar Z2 is minus 2 Z1 bar Z2. This into this minus 2 Z1 Z2 bar, and now this into this minus into minus is plus Z1 into Z1 bar is mod Z1 square, Z2 bar into Z2 is mod Z2 square. So, it will be mod Z1 square into mod Z2 square. Now, observe it, minus 2 Z1 Z2 bar cancels, minus 2 Z1 bar Z2 also cancels. Now, let us write the remaining terms in a proper form. First, mod Z1 square into mod Z2 square minus mod Z1 square, and this one going that side it becomes minus 4 mod Z2 square, and what is the remaining? Plus 4 is equal to 0. Now, what can you do now? This can be factorized. From these two mod Z1 square is common, and from these two minus 4 is common. So, you can easily factorize mod Z1 square into mod Z2 square minus 1. From these two minus 4 is common, minus 4 into mod Z2 square minus 1 is equal to 0. Now, factorize mod Z1 square minus 4 into mod Z2 square minus 1 is equal to 0. But see this condition, mod Z2 is not equal to 1. So, mod Z2 square minus 1 cannot be 0. So, the other factor must be 0. So, what we get? We get mod Z1 square is equal to 4. If mod Z1 square is 4, mod Z1 is plus 2, because modulus cannot be negative, we take only positive square root 2. So, answer is 2. This manipulation should be remembered. Whenever there is a question on modulus, immediately try to use this property. Now, next question. This is a question based on geometrical interpretation of complex number. What is the question? If mod z plus 2 plus mod z minus 2 is equal to 6. Then find the minimum value of mod z plus I. First you need to understand what is the given condition geometrically. Geometrically, mod z1 minus z2 or mod z2 minus z1 denotes the distance between the complex numbers z1 and z2 on the Argand's plane. So, this is the distance of z from minus 2. You can write this as mod z plus 2 is equal to mod of z minus 2. It is the distance of the complex number z from minus 2. Minus 2 is a real number. Then how to represent it on Argand's diagram? Take x axis and y axis. All real numbers lie on x axis. And where is the real number minus 2? It is somewhere here. Now, distance of z from minus 2. Suppose z is here, then the distance of z from minus 2 is this, plus distance of z from plus 2. Plus 2 will be here. The sum of the distances is constant. Let us denote the point z by p and this by a, this by b. So, what is the given condition? Pa plus pb is 6. When a and b are fixed points, p moves such that the sum of the distances from a and b is equal to constant, and the locus of a point which moves such that the sum of its distances from two fixed points is constant is an ellipse. So, the path of P is going to be an ellipse with A and B as foci. So, A is one focus, B is another focus. Okay. So, this is the locus of Z. So, all complex numbers Z satisfying the given condition move on this ellipse. Now, what do you want? You want the minimum value of mod Z plus I. Again, write mod Z plus I as mod of Z minus of minus I. It denotes the distance of Z from the point minus I. Where is the point minus I? Minus I can be written as 0 plus minus I. It represents the point 0 comma minus 1. Where is it? 0 comma minus 1 will be somewhere here. Now, as Z moves on this circumference, what is the minimum value of mod Z plus I? What is the minimum distance of any point on this ellipse from 0 comma minus 1? It is this. But how to calculate it? We need to calculate the equation of the ellipse. You need not calculate the equation of this. You have to find this length. If you can find this length, what is this length according to standard form? It is b. This is denoted by a, this is denoted by b. And from the formula of ellipse, the distance between the foci is 2ae. What is 2ae? It is distance between a and b, 4. So, ae is equal to 2. And according to the definition of the ellipse, Pa plus Pb is 2a. So, we will get a is equal to 3. A is equal to 3 and AE is equal to 2. Then from the formula of ellipse, how to calculate B? You know the formula, B square is equal to A square into 1 minus E square, that is equal to A square minus A square E square. A square is 9 minus A square E square is 4. So, we are getting 5. B square is 5. So, B is equal to root 5. So, this length is root 5. Then what is the minimum distance of Z from 0 comma minus 1? Mod Z plus I minimum is equal to this length B minus this length 1. So, what is it? Root 5 minus 1, that is the minimum value of mod Z plus I. Unless you understand the question geometrically, you won't be able to solve it. Okay. Let us move on to next question. If mod Z minus 4 by Z is equal to 2, find the maximum and minimum values of mod Z. This is also a very important model in which you need to apply triangle inequality. What is triangle inequality in complex numbers? The triangle inequality in complex numbers is mod of mod Z1 minus mod Z2 is always less than or equal to mod Z1 plus or minus Z2 less than or equal to mod Z1 plus mod Z2. You can take either plus or minus sign in the middle. This is called triangle inequality. Now, in this kind of question, you must solve it by triangle inequality only. So, I will take Z1 as Z and Z2 as 4 by Z. Then I will write triangle inequality for Z and 4 by Z. Mod of mod Z minus mod of 4 by Z will be 4 by mod Z is less than or equal to mod of Z minus 4 by Z less than or equal to mod Z plus 4 by mod Z. Now, this is given as 2. Now, mod of mod Z1 minus 4 by mod Z2 is less than or equal to 2. Let us take the first part of the inequality. Now, for maximum value of mod Z, when mod Z is maximum, 1 by mod Z will be minimum. So, which is larger among mod Z and 4 by mod Z? Mod Z will be larger. So, if you open the mod, it will be mod of mod Z minus 4 by mod Z is less than or equal to 2. Now, let us simplify it. Multiplying both sides by mod Z, it is mod Z square minus 4 less than or equal to 2 mod Z. Now, let us take this 2 mod Z this side and 4 that side, then you will get mod Z square minus 2 mod Z is less than or equal to 4. Adding 1 on both sides, left hand side becomes mod z minus 1 whole square. It is less than or equal to 5. Take square root, mod z minus 1 is less than or equal to root 5. So, mod z is less than or equal to root 5 plus 1. So, mod z maximum is given by root 5 plus 1. Therefore, mod z maximum is root 5 plus 1. We got one answer. Now, we have to calculate the minimum value of mod z. For minimum mod z, we have to write it as 4 by mod z minus mod z. After opening the mod, it will be either this or 4 by mod z minus mod z. So, by taking mod z minus 4 by mod z, we will get the maximum value, and for minimum mod z, we will open the mod here and write it as 4 by mod z minus mod z is less than or equal to 2. Now, let us simplify. Multiplying both sides by mod z, it becomes 4 minus mod z square is less than or equal to 2 mod z. Taking mod z square to right side, we will get mod z square plus 2 mod z is greater than or equal to 4. Adding 1 on both sides, LHS becomes mod z plus 1 whole square is greater than or equal to 5. Applying square root, mod z plus 1 is less than or equal to root 5. So, mod z is less than or equal to root 5 minus 1, sorry, greater than or equal to. Mod z plus 1 is greater than or equal to root 5. So, mod z is greater than or equal to root 5 minus 1. So, that root 5 minus 1 is the minimum value of mod z. Therefore, mod z minimum is root 5 minus 1. So, we got both the answers. So, mod z lies between root 5 minus 1 and root 5 plus 1. So, if you locate the locus of z, since modulus of z lies between root 5 minus 1 and root 5 plus 1, if you draw a circle with radius root 5 minus 1 and another circle with radius root 5 plus 1, one is root 5 minus 1, this is root 5 plus 1, origin is center. All complex numbers satisfying this equation lie in this ring, because mod z lies between root 5 minus 1 and root 5 plus 1, and modulus is mod z is distance of z from origin. So, if the distance of z from the origin varies between root 5 minus 1 and root 5 plus 1, z lies in this ring. Okay. Next question. If A, B, C are distinct integers and omega comma omega square are the non-real cube roots of unity, then find the least value of mod A plus B omega plus C omega square. This is a nice question, and similar question was asked in JEE some time back. already we have discussed in one of the previous questions that in problems involving modulus, usually we use the property mod z square is equal to z z bar. So, I am going to try that only. I want the modulus of this, so I will take square of the modulus. Modulus of a plus b omega plus c omega square whole square I will take. If I can find the minimum value of this, then by applying square root we get the answer. What is the square of this modulus? It is a plus b omega plus c omega square into its conjugate. Here a, b, c are distinct integers, they are real. So, the conjugates of a, b, c are a, b, c, and conjugate of omega is omega square, conjugate of omega square is omega. So, its whole conjugate is going to be a plus b omega square plus c omega. Now, multiply a into a square. Next, b omega into b omega square is b square omega cube is 1 because omega is cube root of unity. Similarly, c omega square into c omega is c square omega cube is 1, so it will be plus c square. Next, remaining a into b omega square plus b omega into a, it will be plus ab into omega plus omega square. Similarly, b omega into c omega square, b omega into c omega is bc into omega square, c omega square into b omega square is bc omega power 4. Omega power 4 is equal to omega because omega cube is 1. So, it will be plus omega. Similarly, we will get Ca into omega plus omega square. And what is omega plus omega square? It is minus 1. The relation between the cube roots of unity is 1 plus omega plus omega square is 0. Therefore, omega plus omega square is minus 1. So, this is going to be a square plus b square plus c square minus ab minus bc minus ca. And it is better to remember this is a formula. The product of these two is equal to directly a square plus b square plus c square minus ab minus bc minus ca. You remember it directly, no need of writing this calculation. And now, this expression can be expressed as half into a minus b whole square plus b minus c whole square plus c minus a whole square. And this also should be remembered directly. Whenever you get a square plus b square plus c square minus ab minus bc minus ca, and usually we write it like this. Okay, now let us come to the question. We want the least value of this. So, if a, b, c are distinct integers, what is the least value of this expression? If a, b, c are distinct, what is the minimum difference between a and b? 1. So, this is greater than or equal to 1, half into, it is greater than or equal to, minimum value of this is a minus b whole square is 1. Minimum value of b minus c whole square, it is also 1, because b and c are distinct integers, minimum difference between b and c is 1. plus, what is the minimum value of c minus a whole square? C and a are distinct integers, so c and a will have minimum difference 1, but when a and b differ by 1, b and c differ by 1, then c and a differ by minimum 2. So, the minimum value of c minus a whole square is 4. So, this expression is greater than or equal to half into 1 plus 1 plus 4. What is it? This is 6, 6 by 2, 3. So, the least value of mod a plus b omega plus c omega square whole square is 3. Therefore, mod a plus b omega plus c omega square is always greater than or equal to root 3. So, our answer is root 3. Okay. Next question. If Z1 and Z2 are distinct non-zero complex numbers such that mod Z1 square into Z2 minus mod Z2 square into Z1 is equal to Z1 minus Z2, find the value of Z1, Z2 bar. As we have discussed, since modulus is there, let us try the property mod Z square is equal to ZZ bar, but how to try? Let us see. First, taking this one that side and this term this side, what do you get? Z1 into 1 plus mod Z2 square is equal to, taking minus Z2 this side, you will get Z2 into 1 plus mod Z1 square. Then Z1 by Z2 is equal to 1 plus mod Z1 square upon 1 plus mod Z2 square. 1 plus mod Z1 square by 1 plus mod Z2 square is real, is a positive real number. What is the property of a purely real number? If Z is purely real, then Z is equal to Z bar. Immediately you should use this property. If Z is purely imaginary, then immediately you should use the property Z is equal to minus Z bar in any question. So, since this is real, immediately write Z1 by Z2 is equal to its conjugate. What is the conjugate? Z1 bar by Z2 bar. Now, cross multiplying, we get Z1 Z2 bar is equal to Z1 bar Z2. So, by observing the given equation and modifying, we got to understand that Z1 Z2 bar is equal to Z1 bar Z2. So, in order to calculate this, you can calculate Z1 bar Z2 also. Okay. Now, I will proceed with the property that we discussed for modulus. Mod Z square can be expressed as ZZ bar. So, I will write mod Z1 square as Z1 Z1 bar into Z2 minus this one, mod Z2 square can be written as Z2 Z2 bar into Z1 is equal to Z1 minus Z2. Now, how to proceed? We can take Z1 common from these two and Z2 common from these two. So, taking Z1 this side and taking Z1 common, Z1 into Z1 bar Z2 minus 1, taking Z2 this side and taking minus Z1 common, minus Z2 common, you will get minus Z2 into what is remaining? Z1 Z2 bar minus 1 equals to 0. How can you write it further? It is Z1 minus Z2 into, we already proved that Z1 Z2 bar is equal to Z1 bar Z2. So, these two factors are same. So, we can write Z1 Z2 bar minus 1 is equal to 0. And given that Z1 and Z2 are distinct non-zero complex numbers, so this cannot be 0, we can cancel this. So, what is the remaining? We get Z1 into Z2 bar is equal to 1. This is our final answer. Okay. Now, let us proceed to the next question. Find the number of 25th roots of unity which are also the 30th roots of unity. 25th roots of unity are the roots of the equation x power 25 is equal to 1 and 30th roots of unity are the roots of the equation x power 30 is equal to 1. How many roots of the first equation are also the roots of the second equation? Means how many common roots are there? That is the question. Let us find 25th roots of unity. What is the method? X is equal to 1 power 1 by 25. How to find the values of 1 power 1 by 25? 1 power anything is 1, but 1 power 1 by 5 should have 25 values. How do we get them? We have to write first 1 as cis 0, cos 0 plus I sin 0, cis 0 whole power 1 by 25. Cis 0 means cos 0 plus I sin 0. Now, in order to get all 25 values, we write this argument 0 as general argument. If the argument of a complex number is theta, its general argument is 2k pi plus theta. So, we have to write this as cis 2k pi plus 0 means 2k pi whole power 1 by 25, where k is any integer, but we know that it will have 25 values. So, we take 25 consecutive values of k starting from 0. So, k is equal to 0, 1, 2 and so on till 24. Then by de Moivre's theorem, this can be expressed as cis 2k pi by 25, where k has values 0, 1, 2, 3 up to 24. Actually directly you should be able to write, if x power 25 is equal to 1, you should be able to write x is equal to directly cis 2k pi by 25. That is a formula for nth roots of unity. In the same way, if x power 30 is equal to 1, immediately you will get the 30th roots of unity as cis 2m pi by 30, where m is any integer actually, but we should take 30 consecutive values of m, 0, 1, 2 and so on till 29. If you are aware of the method of finding nth roots of unity, directly you will be able to write this step and immediately this step. Now, we want the number of common roots. So, let us equate them. If these two are equal, then we will get 2k pi by 25 is equal to 2m pi by 30. Then you will get k by 5 is equal to m by 6 by cancelling 2 pi and common factor 5 here in the denominator. Now, observe the values of k and values of m. How many ordered pairs k comma m satisfy this condition? So, k comma m will be 0 comma 0, next set is 5 comma 6, next is 10 comma 12, next 15 comma 18, next 20 comma 24, that is all. Only these 5 ordered pairs k comma m satisfy this condition. So, there are 5 common roots of these two equations. This is the normal method, but we can also remember a shortcut formula. The number of common roots of these two equations is equal to the GCD of 25 and 30, the greatest common divisor of 25 and 30. What is it? It is 5. The number of common roots of these two equations is the GCD or HCF of 25 and 30. So, you can remember the formula. You can remember the formula that the number of common roots of the equations x power m is equal to 1 and x power n is equal to 1 is the HCF of m and n. This is the formula. Okay, let us proceed to the next question. If 1 alpha, alpha square and so on alpha power n minus 1 are the nth roots of unity, find the value of 1 by 3 minus alpha plus 1 by 3 minus alpha square plus 1 by 3 minus alpha cube and so on 1 by 3 minus alpha power n minus 1. If these are the nth roots of unity, then we can write x power n minus 1 as n factors. What is the first factor? X minus 1, next factor x minus alpha into x minus alpha square and so on, x minus alpha power n minus 1. We can write x power n minus 1 as a product of these n factors. Now, you apply logarithms on both sides. Ln x power n minus 1 is equal to, what is the logarithm of this product? Logarithm of this product is sum of the logarithms. It is ln x minus 1 plus ln x minus alpha plus ln x minus alpha square and so on, ln x minus alpha power n minus 1. Now, you can easily guess what I am going to do. In order to get this kind of terms, I am going to differentiate on both sides with respect to x. So, differentiating with respect to x. What is the derivative of ln x power n minus 1? It is 1 upon x power n minus 1 into n x power n minus 1. N x power n minus 1 upon x power n minus 1 is equal to, differentiate the RHS, 1 upon x minus 1 plus 1 upon x minus alpha plus 1 upon x minus alpha square and so on, 1 upon x minus alpha power n minus 1. Now, very simple, put x is equal to 3. Putting x is equal to 3, LHS will be n into 3 power n minus 1 upon 3 power n minus 1, and this one becomes 1 by 3 minus 1, 1 by 2, plus the remaining is the given question, 1 by 3 minus alpha plus 1 by 3 minus alpha square plus 1 by 3 minus alpha cube and so on, 1 by 3 minus alpha power n minus 1. So, taking it this side, what is the value of this expression? It will be n 3 power n minus 1 by 3 power n minus 1 minus this 1 by 2. So, this is going to be our answer. Okay. Now, we are going to move on to questions and answer session after 5 minutes. Hello students, now let us start the questions and answer session. We received one question asked by Mr. Gautam. The question is, let A of Z1, B of Z2, C of Z3 be the vertices of a triangle inscribed in a circle with center at origin. If the altitude from A meets the circle at D, find the complex number corresponding to D. It is a very good question. What is given? A, B, C are the vertices of a triangle inscribed in a circle with center at origin. So, let us take one circle and inscribe a triangle. This is A of Z1, this is B of Z2 and this is C of Z3, and center of the circle is origin. Okay. Now, if the altitude from A meets the circle at D, then find the complex number corresponding to D. This is the question. Now, let us take D as some Z. Initially, all these 4 points are on the circle with center at origin. So, what does it mean? All are equidistant from the origin. So, if the radius of the circle is R, then mod Z1 is equal to mod Z2 is equal to mod Z3 is equal to mod Z is equal to say capital R, which is the radius of the circle. Okay. Now, how to proceed? One is this condition, and another condition that Z should satisfy is AD should be perpendicular to BC. If AD is perpendicular to BC, what is the condition? If the line joining two complex numbers is perpendicular to the line joining another two complex numbers, what is the condition? The argument, difference of the arguments of the corresponding vectors is plus or minus pi by 2. If you assume that this AD as a vector, that AD bar will be perpendicular to BC bar. I will write AD bar is perpendicular to BC bar. How do you write the vector AD bar as complex number? You know that a vector PQ bar is given by position vector of Q minus position vector of P, that is OQ bar minus OP bar. Similarly, the vector AD bar is Z minus Z1, where Z is the position vector of the point D and Z1 should be assumed as position vector of the point A. So, this Z minus Z1 is perpendicular to this vector. This vector is BC bar is Z3 minus Z2. If these two are perpendicular, what does it mean? Difference of their arguments is plus or minus pi by 2. So, argument of Z minus Z1 minus argument of Z3 minus Z1 Z2 is plus or minus pi by 2, and we know that this can be expressed as argument of this by this, Z minus Z1 upon Z3 minus Z2 is plus or minus pi by 2. Whenever the argument of a complex number is plus or minus pi by 2, the complex number is purely imaginary. Therefore, immediately we write Z minus Z1 upon Z3 minus Z2 is purely imaginary. If a complex number is purely imaginary, what is the property? That complex number is equal to minus of its conjugate. What is the conjugate? Z bar minus Z1 bar upon Z3 bar minus Z2 bar. Now, when mod Z1 is R, mod Z1 square is R square. Mod Z1 square is R square. Then we can write mod Z1 square is Z1 Z1 bar. So, it is Z1 Z1 bar is R square. So, we can write Z1 bar as R square by Z1. Similarly, mod Z square is R square. Therefore, mod Z can be Z bar is R square. So, Z bar can be written as R square by Z. Similarly, Z3 bar and Z2 bar can be written as R square by Z3 and R square by Z2. Now, I will write the next step here. Z minus Z1 upon Z3 minus Z2 is equal to minus of R square by Z minus R square by Z1 by R square by Z3 minus R square by Z2. Now, R square can be cancelled, then simplify the remaining. This is as it is, Z minus Z1 upon Z3 minus Z2, and after cancelling R square, then simplifying, you will get minus of Z1 minus Z by Z2 minus Z3 into Z2 Z3 upon Z1. Now, what happens? You can cancel this and this. So, from this, finally, what is the complex number Z? It is going to be minus Z2 Z3 upon Z1. Okay. So, answer is minus of Z2 Z3 upon Z1 is the complex number corresponding to the point D. Okay. Now, next question. The next question is, asked by Mr. Karthik, if mod ai is less than 2, where I varies from 0 to n, then the roots of the equation a naught plus a1z plus a2z square and so on an z power n is equal to 0 satisfy which option? Let us take, I am going to apply triangle inequality. What is triangle inequality? Earlier in some of the questions I explained triangle inequality for two complex numbers. Now I am going to apply it for all these n plus 1 complex numbers. Modulus of a naught plus modulus of a1z plus modulus of a2z square and so on modulus of an z power n. The sum of these moduli is always greater than or equal to the whole modulus. Modulus of a naught plus a1z plus a2z square and so on an z power n. This is triangle inequality. Now we can write this left hand side as mod a naught plus mod a1 into mod z plus mod a2 into mod z square and so on mod an into mod z power n is greater than or equal to I think this is 0 only. Okay, this is 0. Now, given that mod ai is less than 2, now if you take 2 in place of mod ai everywhere, it will be definitely true. If this is true, because mod ai is less than 2, even if I replace mod ai by 2, it will be true. So, I will replace 2 plus 2 mod z plus 2 mod z square and so on 2 mod z power n is greater than 0 because equality is not there. Since equality is not there, it is greater than 0. Now, taking 2 common, we can cancel 2. I think there is a mistake in the question. There is some mistake in the question. Let us finish it and see. You can cancel 2 and you will get 1 plus mod z plus mod z square and so on mod z power n is greater than 0. Now, even if I take the series up to infinity, it will be true. So, I will take it as 1 plus mod z plus mod z square and so on till infinity is greater than 0. Now, if mod z is greater than 1, it is always true. If mod z is greater than 1, it is if mod z is less than 1. If mod z is less than 1, then with this is infinite GP. So, what is the formula for sum of the infinite GP? 1 by 1 minus mod z is greater than 0. It is also always true. I think this RHS should be something else. This instead of 0, you should take something like 1 or 2. Let us take 1. If you take 1, then you will get this as 1, okay. Then this is 1, this is 1, this is 1, not 1, 1 is means that it is getting cancelled. So, let us take 2 or 3, then this is 3, then if mod z is greater than 1, it is true. If mod z is less than 1, we will get this is greater than 3. Then cross multiplying, we get some result. 1 is greater than 3 minus 3 mod z, then 3 mod z is greater than 2, mod z is greater than 2 by 3. Some based on this RHS, you will get some of these options. So, this is the method. Okay. Let us move on to the next question. Next question, please. Let A1, A2, A3 and so on An be the vertices of a regular polygon inscribed in a unit circle. Then find the product A1, A2 into A1, A3 into A1, A4 and so on A1, An. This is a standard question. Suppose this is a unit circle. Let origin be the center. A1, A2, A3 and so on An are the vertices of a regular polygon. So, let us take A1, A2, A3, A4 and so on and join them to the center like this, in this way up to An. Okay. Now, join the sides. What is the angle subtended by each side at the center of the circle? It will be 2 pi by n. Total angle is 2 pi and each side subtends an angle 2 pi by n. Now, let us take this triangle separately. A1, A2, this is origin. How to calculate the length of A1 and A2? Length of A1, A2. Radius of this circle is 1 because this is a unit circle. So, OA1 is 1 and OA2 is also 1 and this included angle is 2 pi by n. If you draw a perpendicular from the origin from O to A1, A2, then it intersects the side at the midpoint and it also bisects this angle. So, this angle will be pi by n, this angle will be pi by n since the total angle is 2 pi by n. Then what is the length A1m in this right angle triangle? We know this angle, we know the hypotenuse. Then what is the opposite side? This side is sin pi by n. since M is the midpoint of A1, A2, the length of the side is actually we do not need to do like this because we want this product only. So, take these vertices as nth roots of unity, because we know that nth roots of unity form a regular polygon inscribed in a unit circle. So, I will take these vertices as 1 omega, omega square, omega cube and so on, omega power n minus 1, because they always satisfy this condition. Now, mod A1 A2 means distance between this point and this point. What is the distance formula? It is mod 1 minus omega. Next is mod 1 minus omega square into mod 1 minus omega cube and so on, mod 1 minus omega power n minus 1, right. We can now write it as mod of 1 minus omega into 1 minus omega square into 1 minus omega cube and so on, 1 minus omega power n minus 1. Now, what is the value of this product? You know that x power n minus 1 has factors x minus 1 into x minus omega into x minus omega square and so on, x minus omega power n minus 1. If you remove the factor x minus 1, the product of the remaining factors will be 1 plus x square and so on, x power n minus 1. So, this product is 1 plus x square and so on up to x power n minus 1. Now, what is the value of this product? Put x is equal to 1. Putting x is equal to 1, it will be 1 plus 1 plus 1 plus how many times? N times. So, this product will be equal to n. So, answer is n. We do not need to calculate like this. Okay, that is the end of this session, and tomorrow we are going to discuss some important questions from the DRS of this week. Okay, be prepared to ask some questions from the DRS of this week from Monday to Friday, right. Thank you, have a good day.
Yeah, good morning students. Welcome back to physics class. The last class we were discussing about work power energy, and we have done some questions also. And work power energy is very conceptual in the sense that how the energy is transmitted from one object to the other object, you will be understanding that. So, as you know, physics is a way of studying how the energy is exchanged between the bodies, right. That way this particular topic is very important conceptually also. Next we will go with the next topic, that is center of mass calculations and conservation of linear momentum. Okay. So, where is the center of mass coming here? And when we were studying about Newton's laws of motion, okay, when we were studying about Newton's laws of motion, there we were mentioning that whenever you are taking FBD, alright, you take all the objects which are having common acceleration. The FBD should be taken, system has to be taken in such a way that you have all the subparts have common acceleration. Then only you will be able to solve the question easily. That was one idea we were mentioning it. Subparts of a system should have common acceleration, then you will get that common acceleration when you apply Newton's laws of motion. But suppose subparts are having different acceleration. For example, let us say you have a system like this, okay, you have a system which is not like this, forget about this condition. Imagine that you have a system in which there are subparts. You have one subpart like this, another subpart, suppose 3-4 subparts are there, okay, and each subpart is having different acceleration. This is having an acceleration A1, this is having an acceleration A2, this is having an acceleration A3, and this is having an acceleration A4, something like that. You have accelerations. Now if you consider the forces, imagine that there are forces acting on it, okay. So there is F1, alright, F2, then let us say F3, and then F4, something like that. You have so many forces acting. Not only these forces, there will be internal forces also. There will be internal forces, force between these two, okay, F12, F21, force between these two, F14, F41. Now it becomes pretty clumsy. There are so many forces, some internal forces are there, some external forces are there. Similarly, force between these two, there are so many forces. When I write Newton's law for this, okay, NLM, when I write F net equal to mass into acceleration, okay. If I write Newton's law for this body, you will get m1 into a1. If you write Newton's law for this part, you will get m2 into a2. If you write Newton's law for this part, you will get m3 into a3. For this, you will get net force is equal to m4 into a4, like that. If I sum up all of them, you will see that internal forces will cancel out, only external forces will remain, F external only will remain, internal forces will cancel out. That will be equal to m1 a1 bar plus m2 a2 bar plus so on, like that you will be getting. So different bodies are having different acceleration. F net external is equal to mass into acceleration of each body, m1 a1 bar plus m2 a2 bar plus m3 a3 bar. This is what you get. If all of them are having common acceleration, that a1, a2, a3 will come out of the entire summation, you will get total mass into acceleration. That is what the condition we wanted to have in FBD in Newton's law. If different subparts are having different accelerations, then Newton's law would be, I will just mention it like this. In general, NLM for a system of particles, okay, NLM for a system of particles, alright, sigma F external will be equal to sigma mi ai. This is Newton's law for system of particles. Sigma F internal will cancel out to 0, only external forces will give you that sigma mi ai. This is Newton's law for total system of particles that you have. But suppose I want to compare it with what we have studied. In physics we do that all the times. Whatever we study already, we will try to study the things that you are doing now whenever there is a possibility to have a comparison, okay. If I imagine, okay, the entire system of particle as single point, okay, the entire mass is present for that only. So what should be, if I have taken it as a particle mechanics for example, so that internal part of the internal motion can be neglected, let us say, okay, internal motion can be neglected. So in that situation, if I write this whole thing as sigma m net into A effective, what is the overall effective acceleration? if I assume that entire mass is assumed to be a single point and I use particle mechanics, okay, then what is that effective acceleration that I will get? From there I will get A acceleration effective will be equal to sigma mi ai by sigma mi, okay, sigma mi. Sigma mi ai by sigma mi, this is called acceleration of center of mass. Center of mass is a hypothetical point. Center of mass is a point, a hypothetical point. It is not a matter particle. It is a hypothetical point whose acceleration will be the acceleration of the point if you assume that particle mechanics is valid. Okay. So, this is called overall motion of the system, orbital motion of the system. As a whole, the entire system is going with an acceleration. This is called weighted average of acceleration. This is called weighted average, weighted with respect to mass. Center of mass acceleration is a weighted average, okay, weighted average of acceleration with respect to mass, that is center of mass acceleration. Purely mathematical idea, once again I will repeat, for a system of particle I am getting it like this, but suppose I assume that particle mechanics expression if I use and try to visualize it in terms of the particle mechanics, what would be that effective acceleration that I have it. So, from there I am arriving at center of mass acceleration, weighted average of the accelerations with respect to their masses, that is center of mass acceleration. Now, once you define center of mass acceleration mathematically, then you need to understand the physical meaning of it. Now, how do I view it, how do I visualize it, center of mass, okay. What are the properties of center of mass, how can I view it, how do I intuitively get the idea of center of mass, those things we would like to understand, right, in physics, okay. So, some important points I will write about center of mass. Number 1, it is not a matter particle, okay. Center of mass is not a matter particle, it is just a weighted average, average of accelerations. For example, let us say you have 2 students in a class, for simplicity I will tell, 2 students in a class if you have, one student got 100 marks, other student got let us say 50 marks. What is the average of marks? 75 marks, no? And that 75 marks was not obtained by any one of them. What does that 75 represent? It represents the overall effectiveness of the effective performance of the average performance of the, it is a kind of a measurement of overall performance, no? Overall performance of the class. Suppose in one class you have average 75 marks, in another class you have average 50 marks, then we can say that in this particular class, first class, the students are performing slightly better, okay, much better in fact than the other section. So, you can get overall performance, these averages and all will give you overall understanding of so many sample points that you have there, okay. So, center of mass is not a matter particle, it is a point in space. It is a mathematical point in space, okay. So, at center of mass matter may be present, may not be present, particle may not be there at all at center of mass, okay. Even if the particle is there at center of mass, particle velocity need not be equal to velocity of center of mass, because center of mass is a space point, whereas matter particle is a matter point, okay. They may coincide. Another point, particle located, a matter particle located at center of mass need not have velocity of center of mass, they may have different velocity also, you will come across that, I think you have seen it also. Particle located at center of mass need not have the velocity of center of mass, but in rigid body, in the case of rigid body, only in the case of rigid body where mass is also constant, okay. In the case of a rigid body with fixed mass, then it is seen that velocity of particle at center of mass equals to velocity of center of mass, Whenever the body is flexible, deformable, velocity of center of mass need not be equal to velocity of the particle located at center of mass. They may have different velocities, like. So that is one important conclusion. Okay. Similarly, accelerations also you can talk about, displacements also you can talk about, and so on. Okay. And how do you find the center of mass? What are the ways of understanding? What is the physical meaning of center of mass? What does it represent? What does it represent? Let us look at what does it represent. Motion of center of mass represents overall motion of the system. Overall motion of the system. Okay, average of a mark, average of class marks will give you overall performance of the system class. No, the same way motion of the center of mass represents overall motion of the system. This overall motion of the system is also called orbital motion. Imagine Earth is going, Earth has got such a complex phenomena that is happening internally. On the surface of the earth, people are moving, rivers are flowing, things are happening, moving up and down, sideways. Okay, within the earth also, at the core there is some molten metal moving, vibrations and all there. And then on the above the surface there is air, gases moving in various directions. There is rain happening somewhere, there is wind happening somewhere, you have deserts there. So much of things are happening all over. Internal motion of the earth is so complex, so complex. But if you look at the motion of the earth around the sun, orbital motion of the sun, earth there, orbital motion of the earth of the sun, in a longer view, if you see from a large distance where the earth appears to be smaller, negligible size compared with the radius of the orbit. Under that scenario, if I observe the orbital motion of the earth, overall motion of the earth around the sun, that will be the motion of the center of mass of the earth there. Okay, center of mass will give you overall motion of the system. Otherwise, larger view, at a longer view, if you look at the entire system, what will be the velocity? Otherwise, let us consider a cloud. Okay, inside the cloud you have water particles. Okay, you have ice particles, maybe there are some gas particles you have, and they are moving randomly. There might be some insects also inside the cloud there. The cloud internally, if you go microscopic view, if you see it, different particles are moving in different directions. But if you come out of the cloud and stand in front of the cloud at about 2 kilometers, 3 kilometers, you will see that the cloud is going as a whole. That overall motion is the average velocity. That center of mass will be given, center of mass will give you the overall motion of the cloud. Okay. Similarly, suppose current is flowing in a wire. When current is flowing in a conducting wire, there are free electrons moving. Okay. And how are the free electrons moving? They will be moving randomly because of thermal agitation due to temperature of the wire there, room temperature. Generally the electrons will have about 300 meter per second, very high velocity. Over and above, because of the electric field, there will be a sideway velocity also, acceleration. So they are moving very randomly, they are colliding with each other, colliding with the lattice and moving in all directions. Again there is electric field, because of that there is a sideway drift. So if you go inside the wire and diminish yourself with the size of electron, the motion of electron would look very chaotic. But if you come out of the wire and you see the longer view, long distance view, you see that the entire electron cloud, we call it as Fermi gas, the entire electron cloud is getting drifted slowly. That should represent the current, drift velocity. Drift velocity is also overall velocity. So motion of center of mass will represent overall motion of the system, not the internal motion of the system, macroscopic motion of the system. Okay, that point I think you need to have very firmly in your mind. Center of mass will give some idea, physical meaning, that is a macroscopic motion, overall motion it will be giving. We also call that as orbital motion. Okay, so that is how you should visualize center of mass motion. Then how to find the center of mass? How to find center of mass? There are very interesting ideas, okay, very interesting ideas are there. There are some experimental ideas also. Actually you know that center of mass is not the same as center of gravity. Okay, center of mass and center of gravity are different points there. Center of mass is the where total motion, I mean total mass appears to be concentrated when you are writing Newton's law. Center of gravity is the point where entire weight appears to be acting. They will not be coinciding in general, but in some situations whenever gravity is uniform, then center of mass and center of gravity will coincide. Okay, and for the tiny objects, small objects like my size or maybe building size, these kind of objects, gravity will not vary much. So when the variation of gravity is negligible, then center of mass and center of gravity coincide with each other, that you must all be knowing it. So whether I identify center of mass or center of gravity, it should not matter as long as gravity is uniform field. I will use them interchangeably whenever the gravity is uniform. They will be different, okay, only when the gravity is, they will be differently located only when the gravity is non-uniform. Of course, the definition of center of gravity is different from definition of center of mass, but they coincide whenever the gravity is uniform. Okay. So how do you find center of mass? Experimentally, if you want to find the center of mass of it, so there are many ways of doing it. So one is, let us say you want to find the center of mass of the pen, for example. What I can do is, I can use my 2 fingers to hold it. Okay, that means center of mass has to be somewhere in between these 2 fingers. So if I want to locate it specifically, maybe if I can hold it like this, of course it is very tough now for me, yeah, I am able to do it. I am able to hold the pen like this, meaning center of mass is located at this point now for this particular pen. So center of mass, weight has to pass through point of support, no, right, that is where you have the center of mass there. This is one way of identifying it. If you have a linear object, no, you hold it with a needle, wherever you are able to hold it straight without having a rotational acceleration, that is the point where you are able to, that you are identifying center of mass location. That is one way of calculating for a linear object. Another way of identifying linear object is, suppose you take the pens, okay, and you keep the fingers at a farther distance initially, okay, and imagine that you keep the fingers at the farther distance. When you are bringing them closer, when you bring them closer, you will see that first left finger moves, then right finger moves, then left finger moves, then right finger moves. At exactly when you are coinciding it, you will see that both the fingers will match or come together exactly at the center of mass. Of course, there is the idea of rotational dynamics there to understand why it is happening, but that is one way of identifying. You keep the pens or supports initially far away, you bring them closer and closer, initially this moves, then this moves, then this slides, then this slides, finally you will see that they will coincide exactly at center of mass. That is one way of identifying center of mass experimentally. Another way of identifying center of mass is, okay, okay, right. So suppose you have a 2-dimensional object. When there is a 2-dimensional object, a planar object is there and you want to find the center of mass of it. It is very simple. For example, I want to find the center of mass of my mobile phone, for example. Okay, imagine that you have mobile phone, you want to find the center of mass of it. What you can do is you hold it at one point and then hang it. So it is going to show some orientation. Then if you imagine a string, you hold a string also here with one support here, one pendulum also you keep, the string will go like this. Okay, you draw a vertical line from the point of center of support, okay, point of support there, you draw a vertical line like this, and then you orient it, you place it somewhere else like this, maybe you can hold it at some other orientation, you draw another vertical line passing through point of support, those 2 vertical lines will intersect, the point of intersection of those 2 vertical lines will be equal to, okay, point of intersection of those 2 vertical lines will be equal to, yeah, center of mass. So center of mass can be identified like this experimentally, and theoretically if you want to calculate center of mass, how do you calculate? Let us take some examples. Maybe I will take one example here, okay, one example I will take. ACM you got it, from there VCM you will get, XCM you will get, let us say RCM equal to, you will write a sigma MIRI divided by sigma MI, fine. and for a continuous mass distribution you will write integral, integral r bar dm divided by integral dm. This is a definite integration, not indefinite integration, initial to final, right, entire body has to be covered, no, that you have it. And whenever mass is uniform, then this will be transformed into dm can be written as, for 3D object, integral r bar dv divided by integral dv volume. 3D object you can use that. If it is a 2D object, integral r bar dA divided by integral dA. For a 1D object, you can write this as integral r bar dl divided by integral dl. Okay. So this is called centroid for a 2D object. If you remember, centroid for a 2D object will be same as center of mass. Whenever mass is uniformly distributed, centroid coincides with center of mass. Okay. This is centroid for 1D object. Okay, centroid, a mathematical term, right? This is a centroid for 3D object. So center of mass coincides with center of mass whenever the mass is uniformly distributed. That point you must all be aware of. All right. Okay, then let us take some examples here. Let us say you have a rectangle. Yeah, you want to find the center of mass. Okay, let us consider uniform mass only. Alright, whenever you have line of symmetry, centroid has to be located at the line of symmetry. This is line of symmetry, LOS meaning line of symmetry, a line which divides the body into two parts, two equal parts, two identical parts which are mirror images of each other. And then if you can identify one more line of symmetry, maybe this line you can consider. This is another line of symmetry about which upper half and lower half are equal. Then the point of intersection of line of symmetry is going to be centroid. Centroid will be equal to center of mass when mass is uniformly distributed. Okay. So very easy to identify if you have symmetry for a uniform body. Similarly, if you consider a triangular plate, for example, triangular plate, triangle uniform mass distribution when you take it, centroid you know it, na? Let us say this point is x1 y1, this point is x2 y2, this point is x3 y3. Okay, the centroid would be there, and it is going to be the point of intersection of median. All right, it is a point of concurrence of medians, right? Medians, this is going to be the centroid. All right, you must be knowing about it. And then if you calculate this distance and this distance, if this is x, this has to be 2x, no? Right, 2:1 ratio it will be dividing. Centroid must be known to you, right? You can directly calculate. Whenever the mass is uniformly distributed, center of mass will coincide with centroid. For a triangle, calculation of centroid is very easy. x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Using that idea, you can calculate center of mass of a triangle. Suppose I give a right angle triangle, for example. Uniform mass I am considering, a right angle triangle I am considering. Then how do you find the center of mass or centroid? Say for example, I will take 0 0. This is let us say A and this is B, otherwise I will write this as H, height, no? Otherwise you can write that as B only. Alright. Let us say this distance is B, for example. Now we want to find the centroid. Okay, this is 0 0. This I can take as A comma 0, taking this as positive x axis. This will be 0 comma B because vertical. No? Now if you want to find the centroid coordinates, no? Centroid coordinates are very simple. xc equal to x1 plus x2 plus x3. x1 and x3 is 0. A by 3 you will get it. And yc will be equal to y1 plus y2 plus y3 by 3. y1 plus y2 is 0, y3 is b by 3. The centroid has to be at a distance very easy to calculate. So you all must be really comfortable with it. This is a distance b by 3. Calculation of a triangular plate, center of a triangular plate has to be very easy. I am assuming that the mass to be uniformly distributed there. For a triangular plate it is at a distance x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Using that idea, you should be able to calculate it. I hope you should all be comfortable with it. Next, suppose we take more examples. Let us say you have a semicircular arc, not a semicircular arc, imagine it is a circular arc, for example, circular arc you have it, and you want to find the center of mass. So first thing that you can look at it, the line of symmetry. You identify the line of symmetry first. If you could identify the line of symmetry, many problems in physics will become easy. Symmetry is very interesting for physics point of view. Mathematically the problem will become very easy. So this is where you have the center, okay, line of symmetry, LOS, line of symmetry. Let us say this is center and this is the radius, for example. So center of mass I have to calculate, I have to identify the center of mass. Integral x dm by integral dm, x coordinate you will get integral y dm by integral dm will give you y coordinate. X coordinate has to be 0, okay, if I take this as y axis now, x coordinate has to be 0, center of mass has to be on the line of symmetry, right, and the center of mass will come out to be somewhere here, alright. The distance also you can calculate, this is a formula you should remember. The distance you can calculate, let us say it is at a distance ycm, the distance you must be able to calculate and you should remember it as a formula. Let us say this angle is theta, then ycm will come out to be equal to r into sine of theta by 2 divided by theta by 2, r sine theta by 2 by theta by 2, this formula you need to remember. I hope you remember it, it will save lot of time. Where theta has to be given in radian, whenever theta is written outside trigonometric function, right, theta must be written in radian. Inside the trigonometric function whether you write in degrees or radian does not matter, but outside when you are writing you should write it as radian only. The total angle is theta, then sine theta by 2 by theta by 2 will be the center of mass coordinate, that small integration you have to do. But suppose I take another example where you have a semicircular ring. Okay, I know in physics there are not many things that you need to remember, most of the things has to be derived and intuitively understood, but in this particular chapter there are certain chapters where certain formulas are there where you need to remember the formulas, and of course there is a logic also to it. First, center of mass has to be on the line of symmetry, and over here theta equal to pi, when you substitute theta equal to pi here, numerator becomes 1, denominator is pi by 2, so it becomes center of mass distance will be 2r by pi. This formula you need to remember. You remember this, you put theta equal to pi, you will get for a semicircle. Otherwise for semicircle it is so common that you will have to remember it, right, 2r by pi. 2r by pi will be the center of mass of a semicircular ring, assuming the mass to be uniformly distributed. Suppose I go for example I will go for a quarter circle, for example. If I go for a quarter circle, okay, you have y here and you have x here and you have a quarter circle, for example, and you want to find the center of mass. Okay, first thing is you identify the line of symmetry. Line of symmetry would be at an angle 45 degrees, no, line of symmetry. Then the center of mass has to be somewhere here, and the distance is r sine theta by 2 by theta by 2, r sine theta by 2 by theta by 2, and that will be r sine theta is pi by 2 here, pi by 4 divided by pi by 4, okay, 4 by pi into 1 by root 2, you will get this as 2 root 2 r by pi. So this distance will be 2 root 2 r by pi. Again here also if you look at this particular length, this length if you calculate, this will be 2r by pi only, same as semicircle you got. Okay, if suppose I add one more quarter circle to the other side, if I add one more quarter circle to the other side, right, and you have the center of mass somewhere here, the resultant center of mass has to be exact at the same height, no? This quarter circle and this quarter circle should have the same y coordinate of center of mass. Okay, and so the resultant has to be at a distance 2r by pi. That means this coordinate should have same coordinate, this also should have the same y. Y coordinates of left quarter circle and right quarter circle has to be same, so that overall center of mass of the semicircle will be at a distance 2r by pi. That way also you can remember it. Okay. For a quarter circle you can have 3/4 of the circle, any amount of a circular arc you can use this formula to find the center of mass. Suppose I use another example wherein you have what color, let us say black color I will consider. A semicircular disc you have, a semicircular disc. If I consider a semicircular disc, so far we consider the ring, now it is a solid one, okay. A semicircular disc you have, it is like a half pizza, a semicircular disc that you have it, you want to find the center of mass of it. So you must remember it as a formula, otherwise there is a easier method of writing it, okay. There is a easier method to write the answer to this. How do you do it? What I will do is, I will cut this semicircle into so many triangles, one triangle, one more triangle, another triangle. You can cut that into so many triangular elements, a lot of triangular elements you can take. Each triangular element subtends an angle d theta. So you can cut that into infinite elements. Each element is a triangle, okay. For a triangle, where is a centroid? Centroid would be at a distance 2/3 of the distance from the vertex, no? 1/3 of the distance from the base, 2/3 of the distance from the vertex, right. The centroid of this particular point would be at a distance 2r by 3, okay. This element, centroid of this particular element will be at a distance 2r by 3, okay. Maybe I will use another color, I will use red color here. Centroid of this particular element is at a distance 2r by 3. The next element will also be having a centroid at a distance 2r by 3. The next element will also have be at a distance 2r by 3, 2r by 3, 2r by 3, 2r by 3. So each element will have a centroid at their respective centroids at a distance 2r by 3. So the elements, each and every triangle element is having centroid at a distance 2r by 3. And now from the reduction method, entire object can be taken as a point mass located at its center of mass to calculate the combination center of mass of the compound object, okay. So this entire element can be taken as point mass at its center of mass. The next element is taken as point mass at its center of mass. So effectively it is reduced into a semicircular arc. It is equivalent to semicircular arc, equivalent to semicircular arc, okay. It is equivalent to semicircular arc of radius equal to 2r by 3, because each triangle element has center of mass at a distance 2r by 3, no? Now for the semicircular arc we have the formula of finding the center of mass. So where is the center of mass that you have? The centroid would be on the line of symmetry, of course, it has to be on the line of symmetry only. And where is it located? Somewhere here you have a centroid located. This distance we have to calculate. YCM will be equal to 2 by pi times of radius of this reduced circular arc. Reduced circular arc equal to how much? 2r by 3, no? So if you substitute it, it will become 4r by 3 pi. This will be the centroid of a semicircular disc which is of having uniform mass distribution. So that way you can do the integration. Of course you can do many ways also, you can cut that into semicircular rings, due to each ring you find the center of mass and then integrate it, that is one method. But otherwise you can cut that into so many triangular elements, infinitesimal elements, each element is having a center of mass is 2r by 3, that reduces a semicircle of radius 2r by 3. Use the formula of center of mass for a circular arc to get the center of mass of a semicircular disc there. So okay, this is one problem you have. Another example I will consider. Suppose I consider a cone, thin conical shell, uniform thin conical shell. Okay, uniform thin conical shell if I consider. So no base here, without base. It's like a birthday cap, right? In birthdays they use, na, kids we wear cap, a conical shaped cap, something like that, without a base, uniform one. It is the thin one I am considering. Now if you want to find the center of mass of this, right, what you can do is, again you can cut that into so many thin triangular elements. You can cut this into many thin triangular elements. This is one element, triangular strip. The next one is something like this. So you can cut that, you can peel that off into so many infinite number of triangular elements. Each triangular element will be having center of mass at its centroid. Centroid will be at a distance 2l/3 from the vertex. Let us say this distance is L, okay, this distance is L. Then each triangular element can be replaced with, I will use some other color. What color should I use? Maybe purple color I will use. This entire triangular element can be replaced with a point mass located at a distance 2l/3, because centroid is at a distance 2l/3, no? Next triangular element also can be replaced with a point mass located at a distance 2l/3. Next centroid also same way. Like that you have infinite centroids, no? Infinite number of triangular elements you will have. All of them will have the center of mass located at a distance 2l/3 from the vertex. So it is equivalent to, the entire cone will be reduced to, it is equivalent to a ring at a distance from the vertex. This distance is 2l/3, okay, and if you look at it, this is h, na, total height is, let us say, capital H, okay. Now you have similar triangles, no? Then this distance has to be equal to 2h/3. This is 2l/3, this is 2h/3. This whole thing is L, this is h. So total L by total h equal to 2l/3 by 2h/3. So from the center of, from the vertex, the centroid at a distance, it has to be at the center. On the axis there is a line of symmetry, no? Every plane has got a symmetry. On the line of symmetry, center of mass has to be there, that will be the center of this ring, okay, reduced ring, and it is at a distance 2h/3 from the vertex or h/3 from the base, okay, h/3 from the base you will have it. For a cone you will have h/3 from the thin conical shell, centroid is at a distance h/3 from the base or 2h/3 from the cone you can have it. So without doing all calculations, I am trying to get the answers by using reduction idea, okay. Suppose I will take another example, thin spherical shell, which is very interesting. Thin uniform hemispherical shell, okay. You have a thin uniform hemispherical shell and you want to find the center of mass to it. So there is one interesting conclusion, okay, that I will show you here. A very interesting conclusion, you will get it. Let us say this is a thin spherical shell, you have hemispherical shell, this is the center. From the center, imagine that I am taking this as a reference line at an angle theta from the line of symmetry, this is line of symmetry, no, at an angle theta. You put a marker inside with a base touching one end of the marker, tip touching the other end of the, that shell, inner part of the shell. At an angle theta, if you rotate it like this in a cone, you will be creating one circular arc like this, okay. I hope you understood. Keep the marker inside the shell at an angle theta and rotate about the line of symmetry at the same angle theta. You will see that you will draw a circle there on the inner surface of the shell there. Similarly, at an angle d theta extra, you put the marker again and draw the line, you will get another circle, okay. In between there is an element, this is the element we will be considering. This element is very famous, lot of times you would have seen this. this width would be equal to r d theta. I am actually enlarging, d theta is very small, no? But I am writing it as a larger one, d theta, and this distance, let us say x, and this distance is y, okay. X equal to r sin theta here, opposite side, and y equal to r cos theta in this particular case, okay. Now what is the radius of the circle here? Now first of all, element is a circular ring, element is circular ring, radius of the element is x only, which is r sin theta, okay, radius of the element is r sin theta, and then circumference of the element, circumference of the element is 2 pi x, which is equal to 2 pi r sin theta. Then width of the element, will be equal to r d theta, this is the width, na? R d theta is the width of the element, circumference is 2 pi r sin theta. Now if you cut the element and spread it like this, it shows like a ribbon, na? It will be like a ribbon. A length of the ribbon will be 2 pi x, width of the ribbon is r d theta. Now if I ask you to calculate area of that element, that will be equal to 2 pi x into width r d theta. So if you substitute it, you will get 2 pi r square sin theta d theta. This is the element area of that element. So I will repeat it once again. At an angle theta, r sin theta, that is the radius of the ring. So circumference of the ring is 2 pi x, which is 2 pi r sin theta. Width of the ring is r d theta. Now I want to find the area that is shaded. So I cut the element and spread it open. You will get a ribbon kind of element. That ribbon will have a length 2 pi x, width r d theta. Area would be equal to length into width, that is area, 2 pi r square sin theta d theta. It is a very common expression, many times it comes 2 pi r square sin theta, 2 pi r square sin theta d theta, of course. Okay, fine, we got dA. And how do I find YCM now? I want to calculate dy here. What is dy, you tell me? Dy by d theta, let us calculate. Dy by d theta, if you calculate, this is r, na? R cos theta, differentiation is minus sin theta, okay. So if you calculate dA by dy, dA by dy, dA by d theta divided by dy by d theta, then you will see that, what do you get? 2 pi r square sin theta divided by minus r sin theta. Very interestingly, very interestingly, dA by dy will come out to be a constant. Negative or positive does not matter, but it is a constant. dA by dy is independent of theta. dA by dy is independent of theta, that is very interesting conclusion. So whatever may be the theta I consider, okay. Suppose I will consider one more element here, I consider one element here, okay, and you take another element here. You have infinite number of elements, na? For each element dA by dy is constant, right? For each element dA by dy is constant. When dA by dy is constant, dm by dy is also constant, because mass is proportional to area, na? dm by dy is constant, okay. Mass per unit length along y axis is constant. So linear mass density along y direction is uniform. That is very interesting conclusion. Linear mass density along y direction, along the line of symmetry, is uniform. So it is having a uniform mass distribution on a surface, that is okay. But with respect to y direction also, it has got a uniform mass distribution. Mass is uniformly distributed with respect to y axis. dm by dy is constant. Very important conclusion. So what is the advantage that I get it here? Suppose I take a spherical shell here, just listen to me carefully. I take a spherical shell here like this, and then I compress it like this, compress it towards the y axis, not moving the particles up and down. If I compress it into a rod, I compress it like this and make it as a rod. If I make it as a rod, it is equivalent to a single rod. I can convert that into a rod. Okay. I want to compress that into a rod. A thin spherical shell, if I compress it like this into a rod, imagine it is aluminum foil. You just compress it and make it as a rod. What kind of rod will you get here? For this also dm by dy will be constant, no? Then this rod would be uniform rod. Okay, this is equivalent to a uniform rod along line of symmetry. Okay, if you focus only on the mass distribution with respect to y axis, uniform rod, uniform hemispherical shell is equivalent to uniform rod. And for uniform rod, where is the center of mass located? In the middle. No? So center of mass has to be at a distance r by 2. For a uniform thin spherical shell, which is hemispherical shell, center of mass is equal to center of mass of uniform rod of same length, radius. Okay. So this is a very interesting observation we have. dA by dy is constant, meaning dm by dy is constant, mass per unit length along y axis is uniform. This particular observation is very interesting to find the center of mass of a thin hemispherical shell. Answer is what? R by 2, very easy to remember also. Okay, right. So some ideas we have taken to find the center of mass for a particular configuration. There are some theorems. Pappus theorem 1, this is one theorem, sometimes it might be useful. Pappus theorem, theorem of Pappus, don't call it, don't pronounce it as Pappus, okay, it is supposed to be pronounced as Pappus, theorem of Pappus, okay, in fact it is Pappus, okay. Anyway, theorem of Pappus, if you look at first theorem, what he says is whenever you have a planar linear object, whenever you have a planar linear object, okay, then you can use the plane of this Pappus theorem to find it. Imagine there is a planar linear object, some linear object is there, it is a linear object on the board, okay, planar, any shape can be there, and you want to find the center of mass of it. For example, imagine you have the coordinate system, I will use the black color. Imagine this is the coordinate system, let us say this is z axis for example. I want to find the coordinate of it. So from here, so let us say center of mass is somewhere here. So what is this center of mass location? This is what I want to calculate. This is a linear object, uniform, of course, uniform mass distribution, linear object, you have it. If you want to find the center of mass of the linear object from the z axis, there is a method he gives. Imagine that length of the wire, length of the object has to be known, length let us say is L has to be given, length must be given. If length is given, then he says one idea, okay, you rotate the wire around the z axis, you rotate the wire around the z axis. For example, let us say you have linear object like this is z axis, you rotate the wire around the z axis, you will get a conical surface, no? So you rotate the wire along z axis, then you will be creating a surface of revolution, okay, we call that as surface of revolution. So this point will go in circle like this, and this point will go on circle like this, this point will go in bigger circle. So each and every point will go in a bigger circle like this, you get a surface of revolution, okay, something like that, you have surface of revolution, you get a surface of revolution. Okay, let us say surface area of surface of revolution, you are creating a surface, no? Let us say surface of revolution has got a surface area S, then surface area S is equal to, what he says is that length of the element into 2 pi RCM, 2 pi RCM. So the center of mass will go in a circle, no? The circumference of the center of mass, circumference of the point, a path taken by center of mass, 2 pi RCM into L. Okay, from here you can calculate RCM. RCM equal to S by 2 pi L. Surface area of revolution divided by 2 pi L will be equal to RCM. Okay. So for example, using this Pappus theorem, if you want to find center of mass of let us say a quarter circular ring, for example, there is a quarter circular ring. Okay, you want to find the center of mass of quarter circle. What is the length of it? L equal to pi r by 2, no? Right? Length equal to pi r by 2, 2 pi r by 4. Then when you revolve it, you will get a surface area of revolution. The surface area of revolution, that will be a hemispherical surface, no? Hemispherical surface area is 2 pi r square. Okay. From the axis, if the center of mass is at a distance RCM, right, for this particular part I am looking at, then according to this expression, Pappus theorem, RCM equal to S by 2 pi L. S is 2 pi r square divided by 2 pi L. L is how much? Pi r by 2. So 1 pi will cancel out, 1 2 will cancel out, 1 r will cancel out. What do you get? 2 r by pi. It is at a distance 2 r by pi you are getting. That will be the distance of center of mass from here. 2 r by pi this side and 2 r by pi this side. From here it is 2 root 2 r by pi. That is what we have derived. Theorem of Pappus, sometimes I am expecting that it might be given as a paragraph question. Okay, if they want to give it as a paragraph question, they can give. Similarly, one more theorem is there. Theorem of Pappus for a planar object. Theorem of Pappus 2. This is for a planar object. Okay, you have a planar object, let us say. Some planar object is there and you want to find the center of mass of this. Okay. So you have the axis of revolution, for example, z axis, let us say. From z axis, center of mass is at a distance RCM. Okay. Now if you revolve it, what do you get? You will get a volume, no? Okay, you will get a volume of revolution. You will get a volume of revolution, right? So the same way, volume of revolution will be equal to surface area into 2 pi RCM. Otherwise, RCM equal to volume of revolution divided by 2 pi surface area of the plane there. The same expression you can use to find the center of mass of a planar object. For that you can use this, you can use for a quarter circle and see whether you are getting this expression or not. Okay, right. So then further we have more ideas. Let us say you have a linear object. Imagine that lambda equal to kx power n. Lambda equal to kx power n. I am assuming this is x equal to 0 and this is x axis, this is x equal to L. Linear mass density is varying with x, imagine. If it is a uniform rod, you put n equal to 0. If it is a linear mass density is linearly varying, you put x is equal to 1 and so on. For any kind of problem, you can use this expression. So we want to find center of mass of it. You can remember it as a formula. I will just derive it quickly. xcm equal to integral x dm divided by integral dm. Integral x dm divided by integral dm, you have it. That is also equal to integral x d lambda is what? Lambda is given lambda dx divided by integral lambda dx. This will be equal to integral lambda is k into x power n dx divided by integral k into x power n dx. So k will cancel out. You will get x power n plus 1 integration divided by x power n integration. X power n plus 1 integration will be L power n plus 2 by 2. n plus 2 divided by n plus 2 divided by L power n plus 1 divided by n plus 1. So if you simplify it, xcm will be equal to, what do you have there, n plus 1 by n plus 2 into L, n plus 1 by n plus 2 into L, xcm equal to n plus 1 by n plus 2 into L, you can have it. Suppose it is linear mass, a uniform mass distribution, that means n equal to 0, then it becomes L by 2. If the mass is proportional to, let us say mass density is proportional to x, you will get what, n equal to 1 if you put 2 divided by 3, 2L by 3 distance. Okay. For various configurations you can write this, xcm equal to n plus 1 by n plus 2 into L, you can just remember that formula. Suppose I want to use this formula to find the center of mass of various situations. Okay. For example, let us say I take a solid cone, when I say cone, understood that it is solid. In physics there are certain standard assumptions. When I say cone, you have to take it as a solid only. When I say sphere, it has to be solid sphere only. Hollow will be specifically mentioned. I want to find the center of mass of it. Okay. So what I will do is, from here at a distance y, I will consider a disc, I will cut that into discs. Okay. I will cut that into discs. Then once I have the disc, right, ycm will be equal to integral y dm by integral dm I can calculate, but I want to calculate dm by dy first. Linear mass density, I want to calculate dm by dy, that will be proportional to dA by dy, no? Dv by dv, no? Dv by dA dy, because it is volume, right, dv by dy. What is the volume of it? You have dv is pi x square into dy divided by dy, dy will cancel out, you will get it is proportional to x square, Okay. When it is proportional to x square, we know that this is x, this is y. Y is proportional to x again, because the angle is constant, no? If it is proportional to x square, it has to be proportional to y square also. That means lambda here, dm by dy, is proportional to y square. Okay. Then go back to the previous formula, ycm equal to n plus 1 by n plus 2 into total length. The total length here is, let us say, capital H, n plus 1 by n plus 2 into capital H. Over here n equal to 2, you just substitute n equal to 2, you will have the ycm for this particular problem. 2 plus 1 by 2 plus 2 into h, that is 3h by 4, 3h by 4 from the top. So centroid would be at a distance 3h by 4 from the top. That means from the bottom it is h by 4. For a hollow cone it is h by 3 from the base. From the solid cone it is h by 4 from the base. You can remember it that way. Otherwise you just simply remember this formula, n plus 1 by n plus 2 into h. Here dm by dy is proportional to y square, that n equal to 2 you substitute, you will get it. Even for a hollow cone also you can write it. There dm by dy will be proportional to x there. So you need to put n equal to 1. When you put n equal to 1, you will get this expression like this. Okay. So this kind of a result also sometimes might be useful. Anyway, we have seen many ways of calculating center of mass, but you need to remember the formula in the examination, right? If you want to save time, right, you need to remember the formula. If you do not remember the formula, you will be wasting time, and again in a hurry you might do calculation mistake also, that will be costly. Okay. Fine. So I told you one important concept, center of mass is a spatial point. Okay. It is a mathematical point. It is not necessarily having the velocity of matter particle. Just to understand that, I will take 1 or 2 examples. Okay. One example, let us take one simple example you have. Let us say this particle has got a mass m, having a velocity v, and this particle has got a mass m and velocity is 2v, and then on the line joining, exactly in the middle, exactly in the middle you have another mass, let us say phi m, r by 2 and r by 2. At one instant I am talking about, at that instant phi m is having a velocity both horizontally, let us say I will take vertically, phi m is having a velocity let us say vertically v. So there are three particles here, particle A, particle B, particle C. A and B are having velocities in x direction, whereas B is having velocity, C is having velocity in y direction. I want to find velocity of center of mass. Okay. First of all, where is the center of mass? What is the location of center of mass at this instant? What is the location of center of mass? First let us look at these two particles. These two particles will have center of mass here, because equal distance, no? Then these two together taken as a 2m mass can be placed there. The 2m mass and 5m mass are all together, center of mass will be here only, you can check it, center of mass will be here. For the entire system, center of mass coincides with 5m particle. So center of mass and 5m particle, both of them are coinciding. Velocity of center of mass will be equal to m1 v1 bar plus m2 v2 bar, alright, plus m3 v3 bar and so on, okay, divided by m1 plus m2 plus m3, which is not equal to velocity of c. You can check that. Velocity of center of mass is not equal to velocity of c. Just one simple example I have taken. C coincides with center of mass, but particle C has different velocity. It can have any velocity, but center of mass velocity will be some other velocity. So center of mass velocity and center of particle velocity are not equal, even though they are coinciding. So this is one simple example where you will understand that center of mass is a mathematical point. One more question, one interesting question that was asked in Olympiad long time back. Let us take that example. Let us say there is a thin carpet. This is a thin, heavy carpet. Some of you might have seen this. So what I am doing is thin, negligible thickness, and the carpet is very heavy. I think like something like you have at home, now you have carpet, right? So the carpet, what they did was, and that is also assumed to be very flexible carpet, okay, it is easy to bend, it does not resist, okay, resistance to bend is negligible, okay, it is assumed to be flexible, you cannot break it, but you can bend it easily. So we take a carpet like this, and what we did was we took the back end of it and then started pulling it towards this. So I took this end and folded back and then started pulling it with the velocity v, constant velocity. So it is like a pull it back, a rolling, and assume that this entire system is on the ground, okay, ground is rough. Okay, ground is rough, extremely rough, I am taking. When it is extremely rough, no, meaning no slip condition. So it does not slip on the floor, it will only roll over, it will just come out, but it does not slide on the ground there. That is the assumption I am considering. So you started pulling it like this. Suppose you focus on after some time, let us say this is t equal to some 0, something like that. At some other instant if you observe, I will use the blue color only, maybe somewhere here you have carpet and then it has been bent like this and moved out, okay, and so let us say somewhere here we have taken origin, maybe origin is somewhere here, and same here, here also you have origin here, okay, and this is being pulled out with a velocity v, constant speed we are pulling out. So suppose you take this length as L, for example this length is x, for example, okay, let us say this length is x, and this end is let us say we call it as P, this end is A, end A. So, velocity of end A equal to V right side. Velocity of end A is being pulled like this with a velocity V continuously. This end point P is a folding point where it is bent. Okay. Suppose I ask you to find velocity of center of mass of the moving part. So, moving part meaning this part of it is moving, no? Find the velocity of center of mass of moving part, they ask you. So, how do we calculate velocity of center of mass of moving part? This is a very interesting question, very good question. How do you calculate this? Maybe I will use some other color, green color I will take. So, center of mass will be in the middle, no? Because we are assuming that the carpet is uniform. They have to mention it, but that is the assumption. Of course, they had mentioned it in the question. It is a uniform carpet, no? So, center of mass of the moving part will be having a center of mass exactly at this instant. Okay, this is x by 2. All right, this is also x by 2. All right, and what about this distance? Maybe you can take this as r. Okay, now location of A with respect to origin is how much? Location of A with respect to origin, this total distance, that is r plus x, no? That is r plus x. Location of A with respect to origin is r plus x, and we know that velocity of A equal to d by dt of r plus x, and that is given as V, constant. All right, r plus x is the location of the particle A, no? R plus x, d by dt of r plus x equal to V. Very good. Similarly, location of center of mass with respect to origin is how much? With respect to origin equal to how much? Center of mass is here, no? This distance, this total distance, that will be r plus x by 2, r plus x by 2. I think it is going to the border, so that problem is coming. Location of center of mass with respect to origin is r plus x by 2. Then VCM has to be equal to d by dt of r plus x by 2, that is the velocity of center of mass. Okay, so if I calculate dr by dt, the problem is over. What is dr by dt? How much will be the velocity of, how much will be dr by dt? For simplicity of calculation, okay, for simplicity of calculation, I assume that initially this end A was at A, the end A was at O. For simplicity of calculation, I can take O anywhere, I will get extra constant. To avoid that constant, I am assuming that A was initially at O, then A started moving, O is there only, O is fixed to the ground. Okay. And if I neglect the height of this part, okay, if I neglect this height now, if this length is x, right, this length has to be x only. If you want to have a combination, right, what you can do is you can just turn back and place it here, a will come back to here, that means this length must be equal to this length, no? So from here you will get that r equal to x, okay. I am assuming that O is initially coinciding with a, then r will be equal to x. In that case this will be equal to d by dt of x plus x by 2, and this r in the place of r you can put x there, then the problem is over. So VA equal to d by dt of 2x, alright, which is equal to 2 times of dx by dt. From there I calculate dx by dt, that is equal to VA by 2. Then VCM equal to x plus x by 2, meaning 3 by 2, 3 by 2 times of dx by dt, okay. This above dx by dt if I substitute there, I will get that 3 by 4 times of VA. So VCM will be equal to 3 by 4 times of VA. VCM, that is a matter particle or space point, space point, okay. Here mass is getting added here whenever you have a variable mass system, right, or otherwise you see it is not a rigid body, it is changing the shape. I told you one statement, right, whenever the body is not rigid, velocity of center of mass need not be equal to velocity of matter particle coinciding with center of mass, okay. So here the particle on the carpet, if you take a marker and put a mark there, that mark will go with v velocity, because the separation between this particle and this particle has to remain constant. But the center of mass is a background point, space point, that is nothing to do with the matter particle. Sometimes they coincide, sometimes they do not coincide. In a rigid body, if the entire body is rigid, for a rigid body where mass is constant, you will see that center of mass will be fixed to the body. If it is not a rigid body, center of mass will be in the background in space, matter particles will go in with velocity and center of mass will go with some other velocity. Now you see this particular question is very interesting, alright. So we will close it for today, okay. If there are any question and answers we will take it. In this particular question one more point you can study, you can try this question also, okay. Find momentum of the carpet. I want you to calculate momentum in this particular question, okay. Very interesting question this is. It might look confusing also, it might be difficult to understand, but it is a very good question. I want you to spend time on it. But if you look at the calculations and all, it is very clear. Center of mass velocity is very different from velocity of the matter particle, which is momentarily coinciding with center of mass, okay. Right. So anyway, we will close it for today here before the question and answer session, and see if there are more questions we will take on that. Yeah, welcome back. Let us see the questions that are being posted today. Yesterday also there were some questions. Unfortunately, I could not take all the questions. Let us see now. So let us look at this question. A particle is projected vertically upwards with a velocity with a speed 16 meter per second. After some time, when it again passes to the point of projection, its speed is found to be 8 meter per second, okay. So the speed has been reduced. When it comes back to the same point, if energy is conserved, you should have the same speed, no? That means there is a loss of energy. It is known that work done by air resistance is same during upward motion and downward motion. The maximum height attained by the particle is, okay. So work done by the air resistance, we are assuming that it is constant. It depends only on the distance traveled there, okay. So upward motion and then downward motion. Upward motion work done and downward motion work done is same, they are saying, meaning. So the resistance force is independent of velocity. We are assuming that resistance force is constant here. Let resistance force, okay, let resistance force equal to F, okay. Then total work done by resistance force will be equal to F into H plus F into H with a negative sign, okay. F into H going upward, F into H going downward. So this is the total work done that you have it, where F is the average resistance force or whatever it is. So this is what you have. Then work done by gravity will be 0, because you are coming back to the same position. So change in kinetic energy must be equal to minus 2F into h, that is equal to half of m into final speed is 8 square, initial speed is 16 square. Okay. So you will get F into h, some expression there. Then what are they asking? They are asking you to find the maximum height attained. So for that I need to use work energy theorem again. Okay. So only upward motion I will take. Upward motion, if you consider, initial speed is 10 meter per second, sorry 16 meter per second, alright. Final speed at the highest point is 0. Final speed at the highest point is 0 there. Now if I use work energy theorem, work done by gravity would be minus mgh, work done by gravity is minus mgh, work done by that resistance force is minus fh, that will be equal to half m into 0 square minus 16 square. I am using work energy theorem 2 times, work energy theorem only for upward motion and work energy theorem for the entire motion I am using. For the entire motion work done by gravity is 0, only for upward motion work done by gravity is minus mgh. And for the work done by friction, if you consider, right, upward motion and downward motion, they are said to be giving same values there. So you have there 2fh, one relation here, fh you have one other relation, alright. So I think you can calculate from there. So you can probably, what you can do is you multiply with 2 here, you multiply with 2 here, and whatever 2fh you are getting here you substitute here, alright, you will be able to calculate mgh. From mgh you can calculate h there. So I hope you understood the question. Question is very simple only. Only thing that you need to understand that work done by friction during upward motion and downward motion they had given equal value, just I need to substitute there. It is simple use of work energy theorem 2 times. Of course you can't use conservation of energy. So work energy theorem is superior to conservation of energy. Conservation of energy is easier, but its application is limited. Whenever there is a resistive force you can't use conservation of energy, still you can use work energy theorem to solve it. Okay. Yeah, let us see next question. One end of a horizontal fixed track of a gauge L and negligible resistance is connected to a capacitor of capacitance C, okay, charged to potential V0. The inductance of the assembly is negligible. The system is placed in a homogeneous vertical magnetic field of induction B as shown in the figure. So Karthik, figure is missing here. Let me see if I can get the meaning of the question without knowing the diagram. One end of a horizontal fixed track of gauge L is and negligible resistance is connected to a capacitor charged to a voltage V0. The inductance of the assembly is negligible. The system is placed in a homogeneous vertical magnetic field of induction as shown in the figure. After that question, what is the question and what is the diagram? Karthik, sorry, question is incomplete, okay. We will not be able to answer this question because I am not able to visualize the diagram also, it is completely difficult. Probably you try to pose the question once again with complete details, maybe we can see it later. So we will look at the next question here. So if there are more questions, let us see in the next question here what is answer, what any other question if you have. So you can pose any kind of questions, not a problem. You need not use only conservation of energy or only that only. So you can take, because this is a revision program crash course, right? Any kind of questions you can ask, but preferably if you can use such questions which are there, probably we can, I can emphasize this concept is already discussed. So based on that I will be able to solve it, something like that. Okay, look at this question. 3 blocks A, B, C are kept as shown in the figure. The coefficient of friction for each surface of contact is given. Horizontal force 60 Newton acts on the block at t equal to 0. Acceleration of A with respect to C at t equal to 0 is. Okay, Sridhar, this is a 3 block system, block on block kind of a system, okay. So the way I solve it, first what I will do is, I will assume that, okay, anyway the diagram is given. Let us say I want to calculate the friction between A and B. It is going to be static or kinetic, I do not know, but I will have a range. Na? What is the maximum value you can have? Mu mg, na? Mu into m, mu is 0.6 into 10 into 10, and that will give you 60 newtons. Fb can be anywhere between 0 to 60 newtons, okay. FAB can be anywhere between 0 to 60 newtons. Then if you go for BC, the normal reaction is 30 kg weight into 0.1 into 10. So you will get how much? 30. Frictional force between B and C between 0 to 30 newtons. It can be anywhere between 0 to 30 newtons. Okay, go for the last block. Last block, there is no friction here. Okay, so there are only two frictions that are available. Whenever they give that kind of question, right, you assume that both of them are moving together. All the three of them are moving together. So that's like we call it as a proposal and then trying to verification, proposal verification. This is kind of a verification question that you need to look at. So let all the blocks go together, let they all be going together. Okay, in that case what would be the common acceleration? You have it, common acceleration will be F naught. They had given how much? 60 newtons, and then the total mass of the system is 10 plus 20 plus 30, 60. So you get 1 meter per second square. Okay, 1 meter per second square. For them to move together with common acceleration, I will focus on MC first, only MC, because MC has got a single contact force, no? Frictional force, FBC. For FBC to be maintaining that kind of friction, right, that kind of acceleration 1 meter per second, how much should be the friction here? This has to be 30 kg into the same acceleration 1 meter per second square. So you know that FBC has to be 30 newtons. The moment you know that value, you check it. FBC, can it be 30 newtons within the limits? Yes, just within the limits, just within the limits. More than, slightly more than that, they would have slipped. Okay, this has reached limiting situation. Similarly, you go for AB now. You focus on AB. Only block A if I consider, there is a 60 Newton force there. Okay, and imagine that FAB is something like this. So 60 minus FAB, 60 minus FAB has to be equal to mass of it into acceleration. Mass is 10 kg into 1, that has to be 10. Okay, 10 newtons. Then the friction has to be how much? 50 newtons. Then you look for the range there. Is it within the limits? Very much within the limits. Okay. So FAB is within the limits, FBC is also within the limits, it has reached limiting situation. That means the assumption I have taken, let they be moving together, luckily it has become correct only. So that means whatever assumption I have taken, they are all going together with common acceleration 1 meter per second square. That should be the answer. Okay. So this friction problem, especially static friction, when you have, sometimes it will be trial and error. That's okay. That is how the research happens actually. Research kind of things happen always a trial and error. You have hypothesis, then you test the hypothesis. If it is correct, you are lucky. Generally it does not happen like that. If there is a mistake, you again modify the hypothesis, again test it, hypothesis and testing. Before friction, all that in whatever we do in physics, it appears like exact, but once you start with static friction, you will see the reality of how you do the research part. So that you should appreciate the static friction point of view. Okay, anyway, we will close it here, alright. I hope you are following the classes completely. Today I was trying to give the ideas of calculating center of mass. Tomorrow we will be using the idea of center of mass and also conservation of linear momentum questions, collision questions and all, we will look at it. Okay. So we will close it here. Thank you very much for joining.
Hello students, welcome back to this beautiful platform of Yup Master. So till now we have discussed some very important reactions of organic chemistry, starting with Grignard reagent, followed by substitution reaction, and then we covered elimination reaction, and then we covered another important reaction, that is electrophilic aromatic substitution. Yesterday we discussed alkanes and we did a very good number of reactions there over, and we did actually some mechanism based questions also. So if you have missed those lectures, if you are new to this platform, just go to the catch up videos and catch those videos. Okay. So if you have not downloaded the Yup Master app, just download the Yup Master app so that you can catch all the lectures that you have missed, and also you can have daily revision sheet as well as test. Okay. So today's topic of discussion is alkyl halide. Now, since we have covered Grignard reagent and substitution elimination reaction, there are like not much of content needed over here to discuss, but we'll streamline all the reactions that are important, especially the preparation of alkenes, preparation of alkyl halides from alkenes, alkynes, and so on and so forth. Okay, so let's start with the topic. So the first preparation that we are going to carry out is through alkanes. Now, often student ask me, sir, is there any way to memorize the preparation reaction? See, what you have to do, it's a very simple process. Whenever you are doing any preparation, suppose you are doing preparation of alkyl halide. Now remember, we started with hydrocarbon. The first chapter was hydrocarbon as it is written in NCERT. So the preparation would also start in the same sequence. The first preparation should come from alkanes, then it should come from alkenes, then it should come from alkynes, then it should come from alkyl halide itself, then it should come from alcohol, which is the next chapter, then it should come from ethers, then it should come from aldehyde ketone, followed by carboxylic acids and amine. So that is the way you structured out your content. So the structuring is very important, because if you are doing it in a structured manner, then like it is very easy to remember those reactions. Okay, so this reaction we discussed yesterday also. So we said that whenever we want to prepare, okay, so yesterday we discussed this. We said that whenever we want to prepare any alkanes, we need to carry out the halogenation reaction. Now the halogenation reaction of alkanes, okay, so the first is the preparation from alkanes. Now whenever we want to do a preparation from alkanes, we know that we can prepare alkyl halides through a free radical halogenation reaction, right? So we can do a free radical halogenation reaction. Now we did this yesterday, that the alkanes would react with halogens in presence of light, leading to the formation of radicals, and it would combine with those radicals to form a alkyl halide. Somehow there were more reagents that can carry out this reaction. One was SO2Cl2 in presence of light, or we can heat chlorine in presence of light also. Radical would be formed and the reaction would lead to the formation of a alkyl halide. So we are saying that suppose you are taking any alkane, say we are taking this, and to this we are adding bromine in presence of light. Now yesterday we covered that bromine is more selective. So in this reaction there are two types of radical that can be formed. One is this and the other is this. Now we know that because this radical is more stable, so the bromine would get attached to this position and this would be the major product. Because bromine is selective, it will select the more stable radical. So this is the major in this case and this is the minor in this case, right? So whenever you are carrying out a free radical halogenation reaction, what you have to do is, you have to just with bromine you have to form the more stable radical and attach the halogen to that particular carbon. Let us try a question on this now. Suppose we say that we are having a molecule of butane and we are adding chlorine to it in presence of light. So these are the questions that are frequently asked also. So the question says, find the number of monochlorinated product in this case. So just try this, number of monochlorinated compounds that can be formed in this case. Suppose there is a molecule something like this, and to this we add again say chlorine, light. So this says again the same question, number of monochlorinated compounds. So just give a try. Just give a try. It will not take more than like 30 seconds. Just give it a try. Okay. So the first question was, we took a butane and we added chlorine to it. So what are the possible product in this case? We will form one product, which is this. Now because this carbon is attached to 4 different groups, so it means that it is optically active. So this will have 2 isomers. Because whenever such question comes, find the total number of product possible, then you have to see the stereochemistry as well, or the stereo isomers involved with it. And the next compound that we would get is this. So this is not optically active, so this is only one compound. So total we are forming 3 compounds. Okay. So in such questions, what you have to do is, you have to identify the identical hydrogens. Now I know that if I look at this structure, this hydrogen and this hydrogen, they are equivalent. This is 2-degree hydrogen, this is also 2-degree hydrogens. Now this carbon is attached to methyl and a CH2 group. This carbon is also attached to a methyl and a CH2 group. So it indicates that these 2 carbons are equivalent, so their hydrogens will be equivalent. So we can replace either of them, right? Similarly, if we have a CH3 over here, we have a CH3 over here. Both of them are again equivalent. So basically there are 2 positions at which radical can be formed, leading to 2 different monochlorinated product. So let us consider another example which we took, that is 2-methylbutane. Now suppose we are adding chlorine to it in presence of light. Now this hydrogen and this hydrogen, they are identical because they have similar environment. So there is this one, we label this as 1 hydrogen. This hydrogen is different, so this is 2. Then this is a 2-degree hydrogen, this is also different, so this is 3, and this methyl is also different, so this is 4. So there are 4 different types of hydrogen available over here. So what you have to replace the hydrogen by Cl, check for the stereoisomers and calculate the total number of isomers that can be formed. So in this case, if we replace hydrogen by a Cl over here, we get this carbon as chiral because it has 4 different groups attached to it. So if we replace this Cl, we get this. So this will have 2 isomers because it is optically active. This will have only 1 isomer. So if you look at this, if you replace this hydrogen by a Cl, again that carbon is attached to 4 different groups. So this is also optically active. So it will also have 2 isomers. Plus if you replace this hydrogen, then we get structure something like this. So this will have only 1 isomer. So the total compound in this case would be 2 plus 1 3 plus 2 5 plus 6. So in this case 6 is the answer and in this case 3 is the answer. I hope this is clear to everyone. So we can carry out, we can prepare a alkyl halide from a alkane through a free radical substitution reaction. We react with halogen in presence of light, or we can also directly say that take SO2Cl2 in presence of light, we will form RCl plus HCl plus SO2, right? So this is the first preparation from alkanes. Now the second which preparation that comes from is through alkenes. Now if you look at alkenes, now we know that alkenes are nothing but they are pi electron system. So basically what we can do is we can have addition of HX. Now this is a very important reaction of a alkene chapter. Addition of HX is an example of electrophilic addition reaction, because if you consider HX, we are having HF, HCl, HBr, HI. Now among these 4, which is the strongest acid? We know that HI is the strongest acid. So if you consider the rate of reactivity, then HI is the most reactive in addition of HX on a alkene, because HI will deprotonate easily because it is a strong acid, it will form H plus ion and I negative ion. That H plus ion will go to the pi electron system and a carbocation will be formed, and then I negative would attack back. So in this case, if we take an example, suppose we are having a molecule something like this. Now suppose to this we are adding say HBr. Now what happens? HBr is an acid, so it will break into H plus and Br negative. So this pi electron would polarize. We would form a negative charge over here. H plus will go and attack at this position. So we will form this as the carbocation. This is a stable carbocation because it is having a 6 alpha hydrogen, and then Br negative would attack at this electrophilic center and would form a alkyl halide. So this reaction follows, the addition reaction follows Markov-Nikov rule. The reaction follows Markov-Nikov rule. Now what does Markov-Nikov rule says? It says that whenever you are adding a reagent to a pi bond, okay, whenever you are adding a reagent to a pi bond, the positive part of the reagent, in this case if you look at the positive part, H plus and Br negative. So H plus is the positive part of the reagent. Now Markov-Nikov rule says that when you add any reagent to a pi electron system, the positive part of the reagent goes to that carbon which has more number of hydrogen atom. So H plus will simply go and bind at this carbon because it is having more number of hydrogen, and it will form a carbocation, and then Br negative will attack at the positive charge, forming the alkyl halide product. Now this is true when the number of hydrogen on the alkenes are different, on the carbon that is present in the alkenes are different. But suppose when the number of hydrogens on those carbon is same, then what we have to look for? So for that an extension of Markov-Nikov rule was given, which says that whenever you are adding positive part of the reagent will attack to that carbon of the alkene, which will lead to formation of a more stable carbocation. Let us consider a case something like this. Now to this if you add say HBr, okay, this carbon of alkene does not have any hydrogen. Similarly, this carbon of alkene also does not have any hydrogen. So where would this H plus go? So this conventional would fail in this case. So we'd say that H plus if gets attached over here, it will form a carbocation over here. So it forms a carbocation over here. And say if H plus gets attached over here, we'll form a carbocation over here. Now we know through the concept of GOC which of the following among the two is a better or is more stabilized carbocation. Now if you look at this carbocation, this is having total number of 7 alpha hydrogen, 3 over here, 3 over here, 1 over here. So this carbocation is having 7 number of alpha hydrogen, but this is having only 5 alpha hydrogen, 2 here, 2 here and 1 here. So obviously this is more stable, so this would be formed in this reaction, and then Br negative would add at this center and it would form a alkyl halide, right? So let us, I hope this reaction is clear to everyone. Let us do some questions on this. Okay, let us try this question first. We will not do much of a solving here because we have already discussed such reactions in the previous lecture when we are doing substitution reactions. Okay, this is the question. You are adding HBr to this, and suppose we are having this molecule. and you are adding HBr to this. Okay, so we know that these are the addition reactions. So in this case, HBr would add and form a stable carbocation. Obviously, it will form a carbocation over here because we can very easily see that there are more number of alpha hydrogen available at this position. Now, because there is a positive charge just outside the ring would undergo an expansion, forming a species something like this. After this, there would be a 1,2 methyl shift or 1,2 methanite shift, and we get the carbocation at this center. So the Br negative would attack at this center and would form a alkyl halide. Right? I hope this is clear to everyone. Now let us look at this reaction. So there is this alkene, to this you are adding HBr. Now HBr would add on this in a Markovnikov fashion. Now because both of them are same number of hydrogen, so we cannot decide to which carbon this hydrogen will go. So for that we will use the extension of Markovnikov addition. We will say that H plus gets attached to that position, which leads to formation of a more stable carbocation. So H plus would get attached over here and the carbocation would be formed in over here because this is stabilized by resonance, and also because of that methyl group attached at para position to the benzene, it exerts a hyperconjugation effect on the benzene ring, increasing the electron density and stabilizing the carbocation. So in this case we would form this. Okay, so I hope this is clear to everyone. The second preparation which comes is addition of HBr in presence of peroxide. Now this is also known as Kharash effect or Kharash effect, like, okay? So we Indians can pronounce this as Kharash effect. So addition of HBr in presence of peroxide. Now this reaction follows anti-Markovnikov addition. This reaction follows anti-Markovnikov addition, right? Now let us understand the mechanism of this reaction. So directly we can say that if we are having an alkene something like this and to this we add HBr in presence of peroxide, so we will get a anti-Markovnikov product. Now what was Markovnikov product in this case? If we would have added only HBr in this case, then this would have been a Markovnikov addition. So H plus would get attached at this position, carbocation would have been formed, and Br negative would get attached to the 2-degree carbon. So the next question comes is how these reactions proceed. Again, mechanism is an important tool to understand, but if you don't know the mechanism, it is also fine. You can have the conclusion about the reaction as well, because JEE never goes in the detail of the reaction asking what is the mechanism or something like that. If you have a clear conclusion, it is very easy to understand. Now whenever you are taking peroxide, I hope you have done this in GOC, that carbon free radicals are generally generated in the presence of helper. Helper is HELPR. Now what is helper? H means heat, E means electricity, L means light, P means peroxide, and R means radical. So radicals are formed in presence of these species. So whenever you are doing a strong heating, then again it can lead to the formation of a free radical, or you are passing electricity just like we did yesterday in a coal based electrolysis process, we are forming a radical, or you are exposing the compound to the light, then also radical will be formed, or you are doing the reaction in presence of a peroxide, HELPR, helper. So again it will lead to the formation of a radical, and any radical in the reaction would always lead to the formation of another radical. So because you have taken a peroxide in this, so what happens exactly over here? The peroxide bond first breaks homolytically and form alkoxy radical. So it forms a alkoxy radical. So this can also be called as a chain initiation step, because in chain initiation step the first step is the formation of the radical. So once this radical is formed, it will go and collide with HBr. Now this bond of HBr will also be homolytically broken. I have already said that free radical requires helper. Any radical would always react and produce another radical. So this will collide over here. It will abstract this hydrogen, form an alcohol plus HBr. Okay? Sorry. It will form a radical over here, because alcohol is already generated. So H is abstracted, so it will form a radical. Now this radical will go to the alkene, because again radical is approaching, so this pi bond will also break in a radical fashion. So this electron gets shifted over here, this pi electron gets shifted over here. So we are generating two types of radical, one radical at this position and other radical at this position. So if Br radical attaches to this carbon, so the radical that would result is a structure something like this. If the radical attaches this carbon, then the radical formed would be this. Now we know that this radical is more stable because it has more number of alpha hydrogen, right? So this would again in the last step collide with HBr. HBr would break homolytically and a hydrogen will be attached over here, and Br radical is generated. The Br radical generated goes and attack on other alkene molecule and the product formation takes place. So this is the basic mechanism that is operating in this reaction. Now one important point you should understand over here is, if you take HCl, so this is the mechanism of this reaction. Now if you take HCl and peroxide, will HCl and peroxide or HF peroxide give anti-Markovnikov or Kharash effect? No. Now there are with HBr bond, we know that HF bond is stronger than HCl, HCl is stronger than HBr. Because these bonds are stronger, so peroxide is not able to cleave it. It becomes a endothermic process. But if you look at the step coming ahead, so this was one important step and this was one important step. If you look with HBr, both these steps, that is addition of radical on the alkene and then the formation of the product, both these steps in HBr is exothermic. So we say that both these steps in HBr is exothermic. But if we look for HF and HCl, the first step is exothermic but the second step is endothermic. So for HF and HCl, the first step which would be the addition of Cl radical or F radical would be exothermic, but the second step is endothermic. So that is why the reaction doesn't take place. If you take HI, now in HI the first step is endothermic and the second step is exothermic. The first step means this step, second means this step. Also whenever I radical is formed, I radical is stabilized by its large size, the radical get dispersed in the size and the I radical recombines with other I radical to form iodine gas. So basically whenever HF, HCl, HBr, HI or HI peroxide has been given to you, you don't have to carry out the radical mechanism, they will simply undergo ionic mechanism. So they simply undergo ionic mechanism and they would lead to formation of Markovnikov product only. Only HBr in presence of peroxide will give us anti-Markovnikov product. Suppose you have been given something like this, same reaction you are carrying out with HCl peroxide. We know that HCl does not cause anti-Markovnikov addition, so the product would be Markovnikov only. Okay. So I hope this is also clear to everyone. So first reaction we did not addition of HX, second is addition of HBr in presence of peroxide, right? So I will just make way out so that you can see this. HF and HCl, the first two steps, the main two steps in this reaction both are, one is exothermic and the other is endothermic. Whereas for HBr, both these steps are exothermic, hence the reaction is taking place. Okay? So let us come to third reaction, that is addition of bromine. So the third reaction is addition of bromine on a alkene. So there are few points which you should know, that addition of bromine is an anti-addition. Now what do you mean by anti-addition? If one bromine gets attached in one particular plane, then the other bromine will get attached in the opposite plane. Okay, suppose this is the alkene. So if one bromine is attaching from here, then the other bromine will attach from here. So if you look at the mechanism of this reaction, suppose to this we are adding bromine. Now bromine is a polarizable molecule, so it has a negative end and a positive end, or a negative or a positive dipole. Now this pi electron attacks at this Br plus and this Br negative goes out. In doing so, if you know the mechanism, you might understand that we would form a cyclic bromonium ion. Now you can also do like this, you are attaching a Br over here. When you attach a Br over here, there would be a formation of a carbocation over here. Now because Br is having a lone pairs, so those lone pair can attack on positive charge and form a three-membered cyclic bromonium ion. Now why cyclic bromonium ion are formed? Because if you look at this structure, this has a complete octet. All the atoms over here has a complete octet. But if you just attach a Br and leave a carbocation over here, this would not have a complete octet. So a cyclic bromonium ion is formed, and we know that the three-membered cyclic ring is highly unstable because of ring strain, and because also there is a positive charge on an electronegative atom. So what it will do, it will polarize this electron, sigma electron, towards itself. Now this sigma electron can also be polarized and this can be also polarized. Once this is polarized, there would be a development of positive charge over here, and if you polarize this sigma bond, there would be a development of positive charge over here. So when positive charge develops over here, there would be, because it is a 2-degree carbon, so it is forming a more stable carbocation. So the polarization would happen from this sigma bond, and the Br negative would attack at this carbon. So what is happening? Suppose this is your pi bond, so there is a bromonium ion formed over here, right? Something like this, a bromonium ion is being formed. Now another bromide ion attacks from this position and this bromine is cleaved out. So what happens? The two bromine are anti to each other. So in this case we say that the two bromine are anti to each other, right? So addition of bromine is also called as test of unsaturation, because bromine is having a reddish brown color, and when you add this bromine liquid to any organic compound that is unsaturated, the color of the bromine will discharge, because bromine goes and attack at the double bond. Okay. So let us do one important reaction, that is, let us take a cis alkene, and suppose to this you are adding Br2. Okay. Now because this reaction is stereospecific, because there is a bromonium ion formed, the next bromine ion would come from the opposite side of that of bromonium ion. This reaction is basically stereospecific. Now I will make you understand what is stereospecificity in this case. Now because this is a cis alkene and addition of bromine is anti, so just remember this rule, car means if you are having any cis system and to which you are adding a substrate which is doing an anti-addition then would always form a racemic compound. So this is the rule in general addition reaction. The first rule is CAR, that is you are taking any cis compound and to this you are adding a reagent which is carrying out an anti-addition, you get racemic mixture. So we know that this is a cis alkene and you are adding bromine to it, so obviously we will get a racemic mixture. So in this case we would get something like this. I will explain it through mechanism also, but remember the shortcut. If you are very clear with the stereochemistry portion, then it is very easy to understand, but if you are having little difficulty in visualizing the 3D structures, then probably you just have to remember this. So in this case we would be forming this. So just remember this rule CAR. CAR means cis plus anti-addition and racemic mixture. Like how do we remember this? This is a very interesting technique over here. Cis and anti are opposite. Cis means same plane, anti means opposite plane. So whenever a substrate you are adding something which is causing the opposite of that particular stereochemistry, then there is always a formation of racemic mixture. That means suppose you are taking a trans alkene, right? You are taking a trans alkene and you are carrying out any syn addition. Trans and syn are opposite. Trans means opposite, syn means in the same plane. So they are opposite, so it will always lead to formation of racemic mixture. Similarly, there is another rule which is TRAM. In TRAM we say that TR means trans, A is your anti, M is your meso. So in this case we say that if we are taking any trans substrate, any alkene which is trans, and to this we are adding a reagent which is causing an anti-addition, then we always get a meso product, right? So trans and anti are the same thing, right? Trans means opposite, anti also means opposite. So whenever a reactant is added to a substrate that is causing the effect same as that of the configuration of the reactant, then we always get meso. So suppose you are taking any cis compound and to this you are adding a substrate which is causing a syn addition. Cis and syn being the same will always lead to the formation of meso. So in this case if you take say a trans alkene, suppose there should be a hydrogen over here, you are taking a trans alkene and to this you are adding bromine, you would land up in getting a meso compound. So this is what stereospecificity is. These reactions are called as, in this case this reaction is a stereospecific reaction, because when we take different stereoisomers of the same substrate, this is a cis and this is a trans, and we react with the same reagent, we get different exclusive products. So such reactions are called as stereospecific reaction. It means that if you are taking a reactant, the different stereoisomers of the reactant in the same reaction would result in a different exclusive product. Okay. So you can do this just by forming a cyclic bromonium ion, and then you can draw its Sohorst projection, and then Br negative will attack from the opposite side. Then you can do it in the eclipse form and can convert into the Newman projection. So I am not going into the detail of this. If you remember the conclusion, it will also work. Like I am just making you understand the method through which it goes. Okay. So I hope this is clear to everyone. The next comes is the allylic substitution. Now suppose you are taking any alkene and to this you are adding NBS in presence of peroxide. Now NBS is N-bromosuccinamide. In presence of peroxide, this will again undergo a radical mechanism. So in this substrate, a radical would be formed at the allylic carbon because it is resonance stabilized. So a radical would be formed at this position and Br would get attached at this position, or you can also carry out this reaction through bromine light. Any reaction in presence of light would lead to formation of a radical. So, a radical would be formed. In these reactions, the most stable radical are formed and the Br radical will attack at that position. But when you are doing NBS in presence of any polar solvent like say water, so in this case what happens, there is an addition of HOBr, because what happens in this case is this goes through a ionic mechanism. So, initially what happens, a bromonium ion is being formed. Okay, this is happening through a radical mechanism. Whenever you are taking a polar solvent along with NBS, then it will be the addition of HOBr. So, I am not going into the mechanism, I just lead to the important points of it. So, the first a bromonium ion is formed. Now, this will polarize from here because a stable carbocation will be formed. Water will attack at this position and will form something like this. So, again this is also a anti-addition because bromine and OH will be in the different plane in the final product. Also, if you heat this with chlorine, any temperature above 500 Kelvin, so you get again a allylic substitution, right. So, whenever you are carrying out a reaction in peroxide or light, you have to make sure that it is a radical mechanism. Suppose a question comes like this, suppose we are having this alkene and say we are adding NBS, heating or peroxide, that means it is a free radical substitution reaction. So, a radical would be formed over here and we would form this, right. Suppose there is a question something like this. Now, in this case there are two types of radical that can be formed, one is over here and one is over here. Out of these two radicals, this radical is most stable. So, a radical formed and Br radical would attack over here and it would form this as the product. Okay, so, more number of products are also possible in this case because if this radical undergoes resonance. So, a radical would be formed at this point and NBS can also provide Br radical at this position forming a Br over here. Okay. So, we are just doing the resonance of this radical, and also a product can be formed over here also because this radical is also stabilized. Out of those, this will be the major product. Okay. So, this is through the substitution reaction on alkenes. Next comes is the preparation through alkynes. Now, suppose we take any alkyne, this is again a anti-Markovnikov addition and we add HX to it. So, this reaction also follows a Markovnikov addition. So, initially it would form positive part of the ring would attach to this carbon, forming a carbocation over here and X would attack over here. Then in the next step H plus would attack at this position, forming a carbocation which will be resonance stabilized by the halogen and it will form a geminal dihalide. Now, what is a geminal dihalide? Geminal dihalide means the two halogens are attached to the same carbon of the compound. Okay. So, this reaction also follows Markovnikov addition. Similarly, we can add bromine to this because it is a unsaturated compound and we know that bromine adds on the unsaturated compound. So, it will form one molecule of bromine would attack and it would form structure something like this. Because there is still a unsaturation left, so bromine can further react and form a tetrabromide in this case. Right. So, this is a preparation through alkynes, right. So, just have a look. So, addition of HX and addition of Br2. Next comes is the from alkyl halides. Remember the flow. First chapter is alkane. From alkane, how you will prepare? Just carry out a free radical substitution reaction, halogenation in presence of light. Second in that was SO2Cl2 light, right. So, first reaction was through alkenes, second is alkenes. From alkenes you can prepare either through addition of HX HBr in presence of peroxide. Third reaction was allylic substitution, and fourth was addition of HBr. Then third came alkynes. From alkynes you can directly add HX or addition of bromine. So this is how you maintain a flow to remember the reactions. Okay, from alkyl halides. Now how we'll prepare this from alkyl halides? We know that alkyl halides already have a halogen in it, so we have to just replace this halogen with another halogen. So that is why they are called as halide exchange reaction. There are two very important reactions that are often asked in JEE. One is Schwarz reaction, other is the Finkelstein reaction. Now Schwarz reaction is basically used to prepare fluoroalkanes, right? We already said that whenever we are doing the free radical or a halogenation reaction of an alkane, we cannot carry out fluorination because fluorination is highly exothermic. So for the preparation of fluoroalkanes, we need to do a Schwarz reaction. In Schwarz reaction, basically what we do, we take an alkyl bromide or a alkyl chloride and we react this with AgF. Now what it does is, Ag plus has a very strong affinity for halogen ion, it will pull the halogen ion, and AgX would be precipitated and the fluoride ion would go and attack at the carbon, forming a fluoroalkane, right? So look at this example. So this is CH3Br AgF, CH3F plus AgBr. Again a bromoethane on reacting with AgF would form fluoroethane. Now Schwarz reaction can be carried out in presence of AgF, Hg2F2 or SbF3, any of these along with an alkyl halide would form a fluoroalkane, right? Next is the Finkelstein reaction. Finkelstein is basically used to prepare iodide. If you forget, just remember Finkelstein like this. This is a shortcut technique. When you are writing Finkelstein, just write I, something like this, right? So you can write the complete spelling. Finkelstein is something like this. So when you write the spelling like this, you remember that there is a big I over here. So this means that it is used to prepare iodide. So when you are taking any alkyl halide, say chloride or a bromide, and to this you are adding NaI, right? In a acetone, now we know that acetone is a polar aprotic solvent. So this reaction is basically a SN2 mechanism. Now I negative goes and attack at the carbon, Cl negative comes out. Now Cl negative reacts with NaF and forms Na and forms NaCl. Similarly, I negative will go attack the carbon, Br negatives comes out and it will form NaBr. Now the next question that comes in the mind, because I is a better leaving group than Cl and Br, so this Br negative can go back and cleave this Ci bond, this Cl negative can go back and cleave this Ci bond, I will come out and again the same product would be formed. Now this does not happen, reaction comes in the forward direction. Why is it so? Because we are taking acetone, which is a polar aprotic solvent. Now NaCl and NaBr are not soluble in this polar aprotic solvent, so hence they get precipitated out. So this is the mechanism, or this is the idea behind the Finkelstein reaction. So Finkelstein reaction is used to prepare alkyl halide, in which acetone is taken as the solvent, and in Schwarz reaction we are taking silver halide, Hg2F2 or SbF3. Okay. So next comes is the preparation through alcohols, right? This also we have covered a portion of it in the substitution reaction. Now suppose you are taking any alcohol, to this you add SoCl2. Now we know that this reaction is a SNI, intramolecular substitution reaction. So what happens in this reaction? We form RCl plus SO2 plus HCl gas, and the RCl formed, if there is any stereochemistry involved with this carbon, there would be a retention of configuration in this case. Now we have discussed this in substitution reactions, that SoCl2 causes a SNI reaction. If you take SoCl2 along with pyridine, pyridine is generally written as Py, this is an example of a SN2 reaction. what happens again in this RCl is formed, but with a inversion of configuration, plus you get SO2 plus HCl, right. This reaction is also called as Darzon's process. So this is a very important reaction of alcohol. So this generally follows SNI and the second one follows SN2 mechanism. Now you are taking any say PX5 or PCl5. PCl5 also reacts with alcohol in a SN2 fashion and forms RCl plus POCl3 plus HCl. So this also leads to inversion of configuration. So if there is any stereochemistry involved with this carbon, it would undergo the inversion. Similarly, if you take any PX3 or P4, P plus X2, P plus X2 will form PX3. It is again an example of SN2 reaction. It would form RX plus S3PO3. So this would again undergo inversion. So just remember these points. If you are not knowing the mechanism also, but you are having the right conclusion, it will work, right? It will definitely work in these cases. The next reaction is directly reacting with HX. Now with HX, we know that HX is an acid. So what would happen in the first step? HX would break and H plus would come out. H plus would go and protonate the oxygen. Once the oxygen is protonated, it will come out as a leaving group. A carbocation can be formed and X negative can attack on it. So we form RX in this case. So we need to remember that if R is methyl, okay, if R is methyl, that is MEOH, methanol. If you take H plus, you will form MEOH2 plus. Water can leave, but it cannot form a stable carbocation. So in that case, it would be a SN2 mechanism, right? So with R as Me, it is always a SN2 mechanism. Also, if R is 1 degree, it is also a SN2 mechanism. But R being 2 degree or 3 degree, they are stable carbocation, so they can undergo SN1 reaction, right? Now, one problem in this reaction is that if you react ROH with HCl, the problem is HCl, H plus you get protonated ROH2 plus, OH2 plus will leave as water, Cl negative can attack. Now Cl negative is a borderline case nucleophile. It is neither that strong, it is neither that weak. So these reactions are difficult to proceed. So what we do, we take along with this anhydrous zinc chloride. So what zinc chloride does is, zinc chloride protonates, zinc chloride being a Lewis acid, it directly gets attached to oxygen and introduces a positive charge on oxygen, due to which the leaving group tendency of OH increases and OH goes out and the reaction comes to the forward direction. Okay? So just remember this. This is also known as Groove's method. Right? So anhydrous zinc chloride, what it does exactly? It coordinates with the oxygen, increases the positive charge and it pulls out the OH from there, and forming Cl negative can go and attack and form a alkyl chloride. Okay, this is also called as Groove's method. Okay, so I hope this is clear to you. Just have a quick look at these reactions. Okay, the next reaction that comes from aldehydes and ketones. Take any aldehyde or a ketone, react it with a PCl5. Now the shortcut for PCl5 is, PCl5 always breaks into PCl3, Cl and Cl. Just remember this way, these are the shortcut, they are not mechanism based, but they are useful in understanding the reaction. PCl5 basically breaks into PCl3, Cl and Cl. PCl3 will always pick out this oxygen. So it picks out this oxygen forming POCl3, right? Now because this carbon has lost a double bond, so both the chlorine will go and attack at this carbon and form a geminal dihalide. So this is the shortcut in this reaction, right? Say you were doing with alcohol, PCl5, we know that PCl5 breaks into PCl3, Cl and Cl. So PCl3 will pick out this oxygen forming POCl3. Now this H will be taken up by this Cl forming HCl, and this Cl would get attached at this carbon forming RCl. Similarly, if you react with ketone, because PCl3 has picked up oxygen that is doubly bonded to a carbon, so there would be addition of 2 chlorine over there. Similarly with the ether as well, we are not going in the mechanism, I am just telling the shortcut way of remembering these reactions. So PCl3, what it will do, it will pick up this oxygen from over here, so it will form POCl3. Because these two bonds are broken, one Cl will attach over here, one Cl will attach over here, will form 2 moles of RCl. Now this has a very good important mechanism aspect. It can undergo SN2 as well as SNI mechanism, but we are not going to discuss it. We just need to have the conclusion about the reactions right now. Okay, so I hope this is clear to everyone now. From carboxylic acid, now there is one very important reaction, that is Hunz-Deiker-Borodin reaction, or in many textbooks it is also written as Borodin-Hunz-Deiker reaction. So this is Hunz-Deiker-Borodin reaction. What happens in this reaction is, we take any silver salt of carboxylic acid, we heat this with bromine in presence of CCl4. We form RBr plus AgBr plus CO2. We can also take chlorine in this case, but the yield of the reaction with chlorine is less. We do not take iodine, and this reaction does not lead to formation of Ri or Rf. So this reaction works only with chlorine or bromine. With chlorine the yields are less. Now basically in this reaction follows a radical mechanism. So initially it reacts with bromine and forms RC double bond O, OBr plus AgBr, because silver has a very strong affinity for halogen ion. So this will pick out a halogen ion and Br would get attached at this point. Now when you are heating, this bond will break homolytically, we form a radical over here. Now this radical would break homolytically, forming a R radical plus CO2 gas is evolved, right, and this will again combine with Br2 forming a RBr and Br radical. Okay, so this is the mechanism of this reaction. Again, mechanism is not important at all. If you have the conclusion, it is enough for the JEE level. Since you are not going to do a PhD in chemistry, I hope if you want, then definitely it's a very good subject to go ahead, but just remember the conclusion at this point of time. So this is the mechanism of this reaction, but if we take iodine in this case, so what happens if you heat with iodine? We get a ester over here plus AgI. So this reaction is called as Bindholm-Simonini reaction. Now we can go in the mechanism of this as well, that first whenever this RCO radical is formed, this will combine with other R radical and form a ester. So in this case a ester is formed. So if we look at Hunz-Deiker-Borodin reaction, if we say that reactivity, 1 degree alkyl halide will be easily formed if that R is 1 degree followed by 2 degree followed by 3 degree. 3 degree generally in these cases also give elimination reaction, because the 3 degree radical is highly stable, so it can also lead to the formation of an alkene through a elimination reaction. So reactivity of this R, or which alkyl halide will be formed easily, 1 degree followed by 2 degree followed by 3 degree. Okay, so this is the basic of this reaction. Next comes is the aryl halides. So aryl halides can be prepared through a process called as Raschig process. In Raschig process we take benzene, we heat it with HCl and O2 in presence of CuCl2, we form a chlorobenzene in this case. Okay, so there are some more reactions involved over here, the other being halogenation reaction. Now we have already covered this in ES reaction. Now that is the beauty of studying the topics separately, studying the reactions which are important via mechanisms. So we know that in halogenation we take a benzene ring and we take X2 along with FeX3, we form a halobenzene. X in this case is chlorine or bromine, right. I have already said that we cannot carry out fluorination in this case because in fluorination the reaction is highly exothermic and cannot be controlled under laboratory condition. With iodine the reaction is reversible because iodobenzene is formed and the HI formed would reduce this compound back into benzene. So we take some oxidizing agent like HNO3 or HiO3 or HGO in this reaction, which will consume the HI formed and the reaction would go to the completion. Okay. So these are the two basic preparation. The next preparation that comes is from benzene diazonium salt. Now this is again a very important reaction. Benzene diazonium chlorides are also asked in JEE at different levels. So just have a quick recap of this reaction. So if we look at benzene diazonium salt is basically this, we are forming N2 plus Cl negative. So this is the benzene diazonium chloride, right? Now if you heat this with Cu, Cl and HBr, Cu, Cl and HCl, so we form a chlorobenzene in this case. Okay. If you heat this with Cu, Br, HBr, you get a bromobenzene in this case, right? If you heat this with CuCN, HCN, you get cyanobenzene. Now these reactions are called as Sandmeyer reaction. I hope you remember this reaction, Sandmeyer reaction. If you take it with copper and say HCl or copper HBr, if this is HBr, then we form this. This is called as Gaterman. Okay. If you heat with Ki, it forms iodobenzene. This is also called as Gaterman. For fluorobenzene, we need to carry out, we heat this with okay. So I sincerely hope that you know the mechanism of these reactions also. If you also don't know the mechanism of this reaction, this won't cause you much difficulty. Sandmeyer reactions generally proceed through radical mechanism. Now many might not be knowing about it, but if you just note it down that it follows a radical mechanism, we can do the mechanism, but unnecessary it will take a time. Whereas if you look at Ball-Schiemann reaction, so what happens in this reaction is, in all of these reaction, nitrogen is also liberated out. So you need to remember that nitrogen is also getting liberated out. Okay. So this is how fluorobenzenes are prepared, right? So some important reactions are, if you heat this with H3PO2 or ethanol, so this causes the reduction and we form benzene ring. If you heat this with water, we get a alcohol. Now this reaction also follows a carbocation mechanism. So this reaction follows radical mechanism, Ball-Schiemann reaction, take a water heating involves ionic mechanism, that is formation of carbocation. So these are the few reactions that you should remember, like these are the very important reaction of benzene diazonium chloride. So we are not going to discuss the mechanism right away. First try to remember all the reaction. If you know the reaction, just have a quick glance so that you are able to remember all those reactions, okay. Mechanisms are important, but only those mechanisms which can be asked in JEE, we will cover that only. These reactions mechanism are never asked in JEE, okay. So basically, if you look at important reactions, the first reaction is a Woods reaction. Now what happens in a Woods reaction, just we'll quickly cover this. We take 2 moles of RCl and we heat it with 2 moles of sodium in dry ether. So we get RR. This we are covered in alkane. So the second reaction that comes is a Woods-Fittig reaction. Now in a Woods-Fittig reaction, one is alkyl halide and the other is aryl halide. So this is the difference. We heat this with sodium in presence of dry ether. So we get a molecule this something like this. In the third it is Fittig reaction. In Fittig reaction both the portions are aromatic in nature. So we take two aromatic halides and we react with sodium in presence of dry ether and we get this. Now fourth reaction is Ullmann reaction. Now Ullmann reaction basically we take iodobenzene and we react this with 2 moles of iodobenzene, we react this with copper and we form a biphenyl system. So these are the very common reactions of aryl halide. Okay. Now substitution reaction we have covered in detail. If anyone has missed the substitution reaction, you can go to the catch-up videos and have a look at SN reactions. Just have a quick recap. Rx plus aqueous KOH, it will always give, aqueous KOH always carries out a SN2 reaction because it is a strong nucleophile. So it forms ROH plus KX, right. Similarly, if you look at the reaction, Rx plus aqueous KNO2. Okay. So this is again a very important reaction, Rx plus aqueous AgNO2. Now what is the difference in the two reactions? Now in aqueous KNO2 we know that KNO2 is a ionic compound because in this there is a potassium atom, metal is generally forming a ionic bond with a non-metal. So we are having K plus and NO2 negative. Now in NO2 negative the structure is something like this, there is an ionic bond between oxygen and potassium. So here because nitrogen is having the, oxygen is having the negative charge, it will act as a strong nucleophile. It is a basically ambidentate nucleophile. There are two donor sites, nitrogen and oxygen. Because oxygen is having a negative charge, it will go and attack at this carbon and this will come out and we form RONO. So we form alkyl nitrite. So this is the major product. Along with it some minor product of RNO2 will also come out, where this ambident nucleophile can attack from nitrogen. But when you are taking a AgNO2, because AgNO2 is covalent in nature, so the oxygen is binded to the silver through a covalent bond, so it will not have a negative charge unlike KNO2. So basically the attack would happen from nitrogen. Silver ion would polarize the X negative and then the attack would take from NO. So we will form RNO2 in this case, which is called as nitroalkane. So in this case this is the major product and some amount of minor product RONO can be formed, right. So this is the reaction with a ambident SN2 reaction with the ambident nucleophile. Similarly you can have the same reaction Rx plus aqueous KCN. In KCN again there is K plus and Cn negative. Cn negative means carbon is having a negative charge and nitrogen is having a lone pair. Now because carbon is having a negative charge, it is a stronger nucleophile than nitrogen, it will attack and form RCN. So this is the major in this case. Also nitrogen lone pair can attack on R and can form RNC. So isocyanides are minor in this case, right. Same as this reaction because this is ionic in nature. If you take Rx plus say aqueous AgCN, now because in AgCN there is a covalent bond between silver and carbon. So this carbon does not have any negative charge, so nitrogen is more nucleophilic. So nitrogen would attack at the carbon, X would be released out and we would form RNC. This is the major product. Some amount of RCN would also be formed in this case, right. So this is basically substitution with ambident nucleophile. Similarly we can carry out the reaction with KSCN. KSCN is again a ionic compound, K is having positive charge, SCN will have a negative charge. So that sulfur would attack forming RSCN. If we are taking AgSCN then nitrogen would attack and the major product would be RNCS, right. Okay, so this was the basic of substitution reaction. Then in this Also we can have elimination reaction. Elimination reaction was basically of two types, E1, E2 and a E1 CV. E1 CV we have not discussed, we will discuss E1 CV tomorrow, and SNAR benzyne mechanism reactions tomorrow. So we are just quickly revisiting all the reactions. So in alkyl halide basically we have done substitution, elimination, then we did Grignard reagent. Grignard reagent is very important over here. Most of the reaction asked in this chapter are from Grignard substitution and elimination reaction. If any one of you have missed that Grignard reagent portion or is having any confusion, you can go back to the catch up videos and catch those lectures. So let us come to another reaction. That is, if you take a chlorobenzene and to this you are adding say chlorine FeCl3. We know that because chlorine is having lone pair on it, any group that is having a lone pair on it will act as a ortho para dilating group. So in this case we would form a para substituted product. If you carry out a nitration reaction, then we would have a NO2 attached at the para position. Okay, so this is the very basics of the reaction. Tomorrow basically we will discuss E1 CV which we have left till now, and we will discuss SNAR benzyne mechanism, and we will do a very important thing, that is coverage of NCERT. I will bring the NCERT here. You also have your NCERT together when we are conducting this class. I will make sure that you are going through each and every important point that is there in the NCERT, because if you look at the JEE Mains paper, I have scanned the paper very well, I have researched it very well, I have understood that there are some theoretical portions that is there in NCERT that is being often asked, which we often as a student neglect. Okay, so let us look at some problems over here now. Let us have a look at this question first, then I will solve this question for you. Now this says, this is basically a multiple choice question. Consider the following statement and pick up the correct statement. Okay. So here if you look at this, the first statement says that this molecule will react more readily than this molecule in a SN1 reaction. Now we know that in SN1 reaction a carbocation is formed. So whenever a carbocation is more stable, its transition state would be more stable and the reaction rate would be fast. So basically we have to look for the stability of carbocation. So if the carbocation is formed, it will formed over here, and in this case a carbocation will be formed over here. So this carbocation is more stable because oxygen will exert a plus M effect and stabilize this carbocation. So this will react readily than that compound. Okay. Let us look at the second option. There is this a cyclic, rather a bicyclo compound having a bromine at the bridgehead position. Now this says that this molecule will react in a SN1 reaction. This is incorrect because the carbocation formed over here is highly unstable, because this is a non-classical carbocation, and non-classical carbocation cannot attain the planarity of a sp2 carbon. Hence this carbocation is unstable, so this would not react in a SN1 reaction. Look at the third option. This molecule will react this in an SN1 reaction. Okay. So we know that in a SN1 reaction a carbocation is formed. So once you form a carbocation, this will be resonance stabilized. This lone pair would also enter into resonance and we would form an aromatic system, right? So we would form a aromatic system. So this is again a highly stable carbocation. But if you look at this, because this lone pair can undergo resonance with this double bond, so there would be a development of some double bond character in this CCl bond. Because of the development of a double bond in this CCl bond, this bond becomes strong and cannot be cleaved in a SN1 reaction. And also if you cleave this out, you form a carbocation in this position. This is something like a phenyl carbocation which is highly unstable. So this is again the right option. Generally SN1 reaction occurs in polar protic solvent. Yes, true. Now we have already done this in substitution reaction, because this reaction, in this reaction there is a development of charge in the transition state. So the polar solvent stabilizes the transition state more than the reactant, and hence the rate of reaction increases. So SN1 reaction definitely occurs in a polar protic solvent. Okay. So let us take another question. Now this is a question that is given to you. Look at this. Now we are having a 3 degree alkyl halide and alpha beta position there is a unsaturation. Now we are taking NaI and acetone. Now we know that I negative is a strong nucleophile, acetone means it is a polar aprotic solvent. Because it is a polar aprotic solvent, it means that somehow it is indicating that it should be a SN2 reaction. But can SN2 reaction happen in a 3 degree alkyl halide? The answer is no. Why? Because there is a lot of steric hindrance at this carbon, so SN2 reaction does not happen with a 3 degree alkyl halide. But there is no such option where it is written that no reaction. So basically this is an example of a SN2 dash reaction. Now what happens in this reaction? This pi electron shifts over here, the leaving group goes out. Because there is a development of positive charge over here, this I negative can attack. So this reaction is called as a SN2 dash reaction. Now why this dash has been written? Because in a normal substitution reaction, the leaving group was getting replaced by the nucleophile at the same carbon where the leaving group was attached. But in this case, the leaving group is attached to this carbon, but the nucleophile is getting attached to this carbon. So there is something like rearrangement. This is not exactly a we will not call this as exactly as a rearrangement, because there is no rearrangement of carbocation. This is a rearrangement of pi bond. Because of this rearrangement of pi bond, this is called as SN2 reaction. So how do we get these questions? Are there any techniques? Definitely, just have a look at the options. Whenever you are confused, whenever you are skeptical about any answer, just look at the option. First try to figure out what is happening. This is how I figured out that okay, this is a SN2 reaction, but there is a 3 degree alkyl halide, so there cannot be a reaction over here. But there was no such option. So we understood that this pi electron was getting polarized and the Br was coming out. Okay. I hope this question is also clear to everyone. Okay, next is again a very important question. This type of questions is often asked in JEE Advanced. Now we have to pick the correct order of reactivity among the following. Okay, so let us start with say C option, E2 reaction. Now we know that in a E2 reaction, the transition state resembles the alkene. So the more the stable the alkene, the more stable would be the transition state and more would be the reactivity. So we know that in that 3 degrees more reactive than 2 degree than 1 degree. So this is actually absolutely incorrect. Now let us look at this option. This is saying for a SN1, we know that for the SN1 a carbocation should be formed. Okay, because there is a strong electron withdrawing group over here. So this carbocation is highly unstable. So this is also incorrect. Now let us look at option 1 and option 2. Now if you remove this, you form a carbocation over here. If you remove this, you form a carbocation over here. If you remove this, you form a carbocation over here. If you remove this, you form a carbocation over here. Now this is a resonance stabilized carbocation, and when you carry out a resonance, the positive charge comes at 3 degree carbon. In this case also it comes at 3 degree carbon. Now this is already a 3 degree carbon, that is a allylic position. Because this is resonance stabilized and the final is 3 degree, here the final is 3 degree, here the final carbocation is 3 degree. Because there is a benzene attached over here, the 3 degree would be stabilized by resonance, this would be stabilized by inductive, and that would be inductive and hyperconjugation, that would also be stabilized by inductive and hyperconjugation. So this is more reactive than this is more reactive than this. So this is the right option. Okay. So just remember this order. If you look at this okay, have a Cl over here. This is more reactive than this. Just write it down if you don't know this. This is a very important data, followed by a okay. If you remove this Cl, the carbocation would be formed. This carbocation would rearrange and form a carbocation 3 degree position. Now when you remove this Cl, there is a carbocation over here, there is a resonance stabilization. Because this is a initially both the carbocation were resonance stabilized, and finally it is forming a 3 degree carbocation which is more stable than a phenyl carbocation. So this is more reactive than this is more reactive than this. So this is again an important question. Now the second option. Now this is again a very important fact that you should know. This can be explained, the first thing can be explained through the interaction of the orbital of C double bond A and the sigma star orbital of CCl bond. we will not go into this. Just remember that any molecule having RC double bond O CH2Cl, any molecule having this skeleton has the highest rate of SN2 reaction. So this is following this. So this is having a highest rate of SN2 reaction. Now if you look at these molecules, now we know that in a SN2 reaction there is only a transition state is being formed. During the transition state, the nucleophile is getting attached to the carbon and the leaving group is getting cleaved out. So in that case, in the transition state there is a development of p orbital. There is a development of p orbital at the carbon. Remember, the carbon was pentavalent and it was sp2 hybridized. So there is a development of p orbital in the transition state. Now whenever there is a development of p orbital, this oxygen will stabilize through resonance. Similarly, this benzene will also stabilize this transition state through resonance, and in this also it will also stabilize through resonance, because after resonance the octet would be complete in this case. So this is more reactive than this. The number of resonating section would be more over here. So this is more reactive than this. So this is again a right option. So if you don't know, if you are just encountering this for the very first time, just write these 2 points in your copy. This can be this molecule had already been asked in JEE once. So this is actually very important. Just have a quick look at the reaction or have a snapshot, or you can revisit it, right? So let us look at this reaction. Now in this reaction there is this SO3 2 negative, okay, and to this we are adding H plus, and we are resulting in the product A, and in the second one we are adding CH3I and we are forming B. Okay, so if suppose I am a student, how do I approach this question? I will look at the option. Okay, so in the first it says that H is getting attached to oxygen and CH3 is getting attached to oxygen. Okay, no issue. It means that there is a nucleophilic addition over here. Okay, so nucleophile is either attacking from oxygen forming OH or OCH3. In one option there is also that sulfur's lone pair is also attacking on CH3 and is forming this. So that means this sulfur is also having a lone pair. So this is attacking at CH3 and forming a substitution product. Now we have to look for the options now. Now in the first reaction, when you are reacting SO3 2 negative with H plus, right? Now H plus is a very small atom, right? So this H plus would definitely go and get attached to the oxygen. So it would form something like this. Okay. So if you forget this, just remember that if one more H plus was taken, it would form H2SO3. So H2SO3 is sulfurous acid. When it lose one H plus ion, it will form HSO3 negative. When it lose other, it will form SO3 2 negative. So obviously this H plus was going to this oxygen, right? Because H plus is also very small, so there is no steric requirement in this reaction. Okay. Now in the second reaction there are two competitive sites. Sulfur can attack as well as methyl can attack. Now because the negative charge on oxygen is resonance stabilized and the negative charge gets distributed, so the nucleophilicity of oxygen is reduced, whereas sulfur has an electron, right? So this electron pair can be donated to carbon and iodine can leave, so it can form something like this. So in the first reaction H plus will get attached to oxygen, whereas in this case it would form this. Okay, I hope this is clear to everyone. So these are the product that is getting formed. Okay, so just have a look at the product and you can predict what is going to happen. Okay, so this is it for today. We have left with 2 or 3 important reactions that we are going to cover tomorrow and day after tomorrow. Basically, if you look at the schedule, I have placed 2 sessions for NCERT now because we have covered sufficient number of good reactions, and after this week we will just start with the important topics, that is alcohols, phenols, carboxylic acid, amines and aldehydes and ketones. So I hope these lectures are very clear to you and you are following everything judicially what has been said to you, and I hope that you are focusing more, you are solving more, you are reading more and you are looking at the previous year paper. That will actually help you in understanding these concepts. Okay, so till now we have covered almost 60% of the important reactions. Now only 30 to 40% is left, but in JEE mains you need to cover NCERT properly. because NCERT has a varied level of theoretical problems that can be asked. So what I would suggest at this point is, if you have downloaded the Yup Master app, just solve the DRS. DRS will give you the sufficient confidence in tackling the JEE mains as well as advanced question. Read NCERT every day properly. Just take out NCERT exemplar book. If you don't have the NCERT exemplar book, you can download it from the government MHRD website also. It's available, it's free resource for everyone. So if you go through that book, NCERT exemplar is also a very important book that covers the basic NCERT as well as some advanced level problem solving. Okay, so I hope you are enjoying teaching at Yup Master, and I hope you are having a very positive review about us. If you have any doubts, any problems, as I am already telling you in every lecture, just post your doubts so that we can reach to you and we can help you in this time where actually some mishappening is happening outside. So I hope you are taking care of yourself. I, Animesh Verma, your chemistry mentor, signing off for now. We will catch tomorrow.